Hey everyone, welcome to this course on data acquisition and manipulation using SQL by Simplilearn, where we will learn how data is stored, accessed, and manipulated using one of the most essential languages in data analytics, SQL, which stands for Structured Query Language. It's the backbone of almost every data-driven application. Whether you're working with analytics, business intelligence, data science, or backend system, SQL is the skill that allows you to retrieve meaningful data, transform it efficiently, and answer real business questions. So in this video, first, we will dive into databases and SQL foundations, where we will cover the evolution of data storage, core database concepts, and the asset properties, along with an overview of SQL commands and setup. Next, we'll explore SQL basics and crude operations, including MySQL workbench, SQL syntax, and best practices. Moving on, we will learn about filtering functions and query control, focusing on logical operators, string functions, and handling null values. Then, we'll cover grouping conditions and time functions, diving into advanced grouping conditions filtering and date time functions. Finally, we will wrap up with joins and advanced data manipulation, where we will learn about SQL joins, table creation, and advanced querying techniques. Now, if you're looking to advance your career in data analytics and generative AI, then the professional certificate course in data analytics and generative AI from ENICT Academy IT Kanpur is designed to equip you with the skills you need to succeed in today's tech-driven world. With masterclasses delivered by IT Kanpur faculty and a program certificate that boosts your professional profile, this course offers hands-on learning through over 215 exercises and 12 plus real-world projects. You will deep dive into data analysis, Python, SQL, generative AI, and AI-powered visualization tools like Power BI and Tableau. With live interactive sessions, you will not only gain expertise in these tools, but also earn Microsoft Azure Data Fundamental certification along the way. So what are you waiting for? Hurry up and enroll, and you can find the course link below. So before we get started, here's a quick quiz to test your understanding. Which SQL clause is used to filter aggregated date? Your options are where, having, group by, or order by. Let me know your answers in the comment section below. Let's get started. Certification along the way. So what are you waiting for? Hurry up and enroll, and you can find the course link below. So before we get started, here's a quick quiz to test your understanding. Which SQL clause is used to filter aggregated date? Your options are where, having, group by, or order by. Let me know your answers in the comment section below. Let's get started.
Let's start with SQL. Now, let's get introduced to SQL, or sometimes you also call it SQL there. Now, let's understand this here. So, for example, here, okay, Netflix is a global leader. Like Netflix, we have got Amazon and several other streaming subscription-based companies out there, right? And they are very, they will give you recommendations. So this is the new movie, but this is the recommended movie based on what you have seen so far, right? It means it will collects the data. It collects the data that when you are watching it. I'm pretty sure most of you have done the the binge watching on Netflix or anywhere else. And after a while, okay, this actually asks you that are you awake? Are you still there? Right. So how do they know that? So they are actually collecting your data. Now just imagine millions of people out there, they are looking at Netflix right now. And whatever they are looking at and whatever media they are uploading there, and however the user is interacting with that Netflix application or the website there, they are collecting the database there. Now that collected content or that collected data altogether here, they are saving somewhere inside the database. They are saving somewhere inside the database, right? So when they have such information here, all right, where they are going to save it. So wherever they're going to save it, okay, that becomes a database. Now that database can be anything. A database here can be anything. These are databases. They can be your servers, okay, they can be your cloud or third-party server or in-premise server or on-premise server. Ultimately, they all are your databases. Ultimately, they all are the databases. So first, what we are going to start with today is we will first start here with database and its types, right? First, we'll talk about that. First, we will only talk about that. only database and their applications. After database and their applications here, I'm going to talk about the TOC. After this here, I will go ahead and I will talk about TOC. It means that what we are going to cover in this SQL program, all right? After the TOC here, we will go ahead and learn about SQL, okay? That how this language is used. What are the clauses out there? What are the commands out there that we should be looking at, right? So I'll go ahead and learn about that too. Once we will learn about that, then we'll go ahead and get introduced to lab, practice lab that is available online, right? That runs on a virtual machine, right? So let's go ahead and get introduced to database here. But before I go ahead and start talking about database, everyone, let's have some few small things straightened out, right? What are small things I'll be talking about here? Because it's just not everyone is using Snowflake, right? A few percentage of the companies use that here. Now, why are we learning SQL here? Because SQL here is the base or foundation language to retrieve data from any database out there. Okay, so since you are using a Snowflake, so we think that oh my God, everyone is using that here, but that is not the case. People are using Oracle also. People are connecting with AWS. Those who are working with Power BI, they're working with Azure there, and most of the companies, those are the older companies, right? Their data is still lies in Oracle, and they are still utilizing that perfectly. So if we are about to learn any kind of language here or towards data engineering, just simply retrieving or connecting my Power BI to any other system or connecting Tableau to any other system out there, or it can be a cloud storage or database there, at least I should know what I'm doing. So as a data analyst or a business analyst here, we should be aware about this, that, okay, how am I connecting my data there? Even if you're a data scientist, you're far away from an analyst or and the data engineer there, you should know how the data is getting here. So if someone provides you a code somewhere or you are having little bugs out here, you will be able to at least understand what is going on. So that's how learning SQL language will help you. It will also help you to understand that how database is actually created. And once you understand that, it will be far much easier to actually analyze the data set and understand from where this will be coming from. And it will actually help you to write the calculations or use the functions effectively. So that's how it works. Okay. Now let's understand here. Now we say that we have social media and everything, and the data is getting collected, and we need to save data somewhere here. But we didn't have the cloud technology before 2000s. It is not available widespread to all the businesses likewise there. In later 2000s here, we get to have our cloud technology, and it was a big boom. And everywhere after 2010, we had social media and too many and two different types of data set there. But before that, also data existed, business existed. Clinical research were happening there, back there too, meaning everyone has the data with them. So where will they saving that? When we didn't have any databases like that at the back end, okay, we were saving everything in the flat files. So whatever data we had, it was getting saved in the flat files here, right? Now you must be thinking that why I'm taking you through here, okay, for the understanding about what is database here, because nowadays we think about database, or it's a cloud, it's a database. But what is actually happening at the backend, let's understand that here. I will be very quick, don't worry about that. So here, let's say we are saving the employee records here. All right. Now these are all going to be simple flat files as I'm typing it right now in the notepad. So for example, if this is the employee data here, maybe I'm going ahead and here we are saving the employee data. So I need my headers like ID, name, designation, employee status, and a lot more. Inside that here, we will keep going here and typing the row by row details of the employees here, row by row details of the employee here, likewise. And like this, we have to go ahead and I will go ahead and write all the 1,000 entries right here. Now, of course, people are leaving, people are joining back again. Okay, so this data will keep on getting edited. So if the 5 people are there and those who are responsible to update this data every time, or have the access to this data here, you'll keep on accessing this data and they keep on adding and deleting that. But everything has to be very manual here, and they have to be very, very careful that what they are doing right here. So if this is a notepad file, simple notepad file here, and we are collecting our data set right here, what do you think here, what can go wrong? In this case, if it's a simple notepad file, it is a simple text file, and we are manually entering the data here. What do you think can go wrong here? There is no data type here. There is absolutely no data type here. Okay, so for example, look here, it is using 1,000 separators. This is not using 1,000 separators. Okay, here we are using uppercase, here we are using lowercase. Again, we are using uppercase. So there is absolutely no data validation. There is absolutely no data validation. Meaning your data type has no meaning. Okay, we cannot enforce that this is the way you should be entering the data set too. Plus, there will be issues with data integrity because we have no idea what someone is typing. Okay, there can be manual errors here. So here comes the question for data integrity. Very good. Now here, if someone will ask us here that, can you get me the list for all the managers out there? It is going to be very difficult here because it is a simple text file. I cannot simply put a filter and get the data out. So here comes that retrieving the data becomes very painful. You have to go line by line, and try to figure out that, okay, this is, and copy paste manually to figure out that, okay, what's going on. So these are the few limitations that we were going to see there. So they have faced these limitations, of course, and then they came up with the database management system. Database management system, they understood that as the technology has progressed, okay, they understood that flat files are a no-go. Okay, that is very, very difficult here. We have got tons of files saved in a computer drive there. And that drive, that is my server. I'm connecting via LAN there. Those who sit there, they can only go ahead and access that file. And still it can have multiple wrong entries there. And of course, it was very, very difficult to update this here. For example, if someone leaves right now, okay, if let's say Dipali is leaving right now. So should we simply go ahead and delete this line that Dipali has left the company? Should we simply go ahead and delete this line here? Why not? She's not working with us anymore. Should we delete this since since Dipali has resigned? So for example, right now we have employee status here, right? So we have to update the employee status, and with that we have to give date of joining and date of resignation too, or date of leaving. We have to update that date too here. We cannot simply go ahead and delete the thing here. This is why this is required. Okay, so now they will keep adding DOJ and date of leaving here. So let's say now this person has resigned. So they have to go ahead and update the status resigned. Now here they have to write DOJ. They have to write again one more status there. And keep on writing the dates. If this person has resigned, this person is active. Of course, they have to go ahead and type NA there. So of course, there is going to be a lot of duplication again. So that's where they came up with the database management system that, okay, this is not working for us. So let's go ahead and they created a database management system. What was the good thing here? Okay, they decided that there are no simple flat files here. Now we are going to go ahead and save everything in the table structure. Now they actually defined the table structure. They said that everything will be saved in the table structure, which is going to contain rows and columns. And the first row that is there, okay, the first row there, it has to be a header. So they came up with the rules there. The first, it should have rows and columns. First row there should be always be a header there. And while you're reading that data set, okay, you should read from top to bottom. Plus, each column header that we are giving, or each column name that we are giving there, each column header should have its own data type, and data written inside it should be written according to that. So if I'm saying it is date of joining, it means inside that column only dates can be written. If I'm writing this is the employee name, only the name of the employee can be written. So they came up with the table structure here, that this is the table structure that should be followed in DBMS. However, in DBMS here, okay, they are simply going ahead and creating a standalone tables. So for example, if I have department table here, right? So a department table will be there. So for I have an entire database with me, but that entire database will have multiple tables, but they will be simple tables there. So employee table is there, department is there, customer is there, and vendor is there, right? Connected to each other. Now, if I'm collecting employee data, I'm simply collecting the employee data as I'm doing there. If I'm collecting department-wise data, I'm collecting department data. If I have customer details there, I have got customer details there. So they were huge. Just imagine your MS Access data or MS Excel files that you have here. So that kind of tables you have. So for example here, okay, now we have employee table and department table in the rows and columns like this. If this is a row and column table here with the proper definition inside a proper MS Access or MS Excel or with that kind of software there, it means we can define the data type, data validation, everything. So all the limitations of the file system there, they became advantage in the database management system. The only drawback here was that if I will ask you, for example, this is department table, right? Now, this was our employee. This is our employee table. This is our employee table. I'm simply going to get this employee table here. Let's just assume right now that both are in the table format. Both are in the table format. This is our employee table. And let's imagine here that both are in the same table format. Now, if I will ask you right now that can you go ahead and get me the manager from marketing department? How you will do that? See here, we cannot do the join here. Why? Because I have department name here, I have got department code here, I have got department code here too. But since these two are not connected here, right? What will I do here? I will find that okay, this is my department code here. Go ahead and find the matching department code here, and okay, this is the marketing. Now, once I know that this is the marketing department code here, now I can go ahead and find okay, which is one, which is one, which is one. It means we can filter it out. Now we can filter it out. So this is what we could have done, but the only issue is okay, we cannot go ahead and we have standalone tables. They were actually not connected to each other. The way they were getting collected, the way they were getting saved. So with the DBMS here, when they saw this is the problem here, and plus the when the data got bigger, okay, they kept on accumulating more data there. It was becoming difficult for them to keep on saving multiple different files there. And if they want to find anything there, okay, they cannot simply join it together like we do nowadays and move on with it. Why? Because it did not have those common columns actually created inside it. If I'm selecting the vendor data there, okay, if I'm having the transaction slips in front of me, only codes are written there. Okay, or if there are no codes there, they are simply using their own names for the product there. So it was becoming very difficult because we have to manually go ahead and figure out, okay, find out that out of these 30, 40 columns, which one is the common to which table there. So they came up with relational database. To figure out these limitations here, okay, now they came up with the relational databases. That is your RDBMS. Now, okay, people started converting their DBMS into the RDBMS here. So what was the objective and why the RDBMS was there? First, of course, everything was saved in the tables here. Okay, everything was in the table structure as before in the DBMS. However, now these table structures were getting connected based on the common columns. Now, from where those common columns are coming from? So now we were creating those relationship between the tables. We were creating those relationship between the tables here. If there were no common columns here, we were creating the common codes, okay, so that we can relate the tables together. And this is the work of data engineer. This is the work of data engineer. They're the ones, those who will interact with the data and make sure in your database, they are extracting data from multiple sources there. And they are, then they are making your data ready to be used by the end user for simple extraction of data, tables or reports out of the server there. So this is how the relational database came into view. Now, whichever database you're working with, no matter what it is a Snowflake or something else out there, right? Will have basic three entities or three components there. What are the three components here? Three components here of any RDBMS here, or three entities are going to be very simple. First thing that you need here is, of course, data that you will be extracting from multiple different sources. So in the MySQL here, whichever database you're working with, it is always based on three entities and three components. What are the three entities here? Three entities here is to create any database. Now we have the definition of database, right? We have the definition of database here. Let's look at the proper definition of the database right now. And then we will see here. So within the database, first word is data. And we have already discussed this word before. What is data here? Data is just the facts, numbers, or any kind of information, whether it's an image, an audio file, a video file, anything out there. Any form of information that is structured in a specific way and is stored for a particular purpose, that is data. Plus, this data can be in several forms. It can be numbers, text, bits, or bytes. It can be stored in several forms too. That is data. Remember that it's structured in a specific way. It is not saying tabular way. No, it is saying any specific way. And then it is stored for a particular purpose. If I'm collecting the data from YouTube comments, it is for a particular purpose. If we are collecting data from my LinkedIn profile or for my GitHub profile there, that is for a particular purpose, right? So that is the data there. Now, what is database then? How do we define a database here? Database here is the structured collection of multiple datasets. They are generally stored together, okay, in one single entity, so that we can access it, manage it, and update it. So what is a database here? Database here has always three entities. What these three entities are? Look at the three entities here. It's structured collection, everyone, right? Then it is saying that it's stored on a computer. It means it has to be stored on a computer, some hardware there. And we also need to access that hardware, manage that, and update that data there by using this hardware here. So we have always three entities. First is your data, right? Second is your hardware. And the third component is the software through that you can access, manage that data easily. So whenever we talk about three components here or three entities here, this is what we're talking about. We're seeing that you have whichever database you're using here, you always have three entities. First is your data. Second is any kind of hardware, any kind of container that can contain data or any kind of hardware there. To access that hardware, we will also have an application program through which we can contact and communicate with that, right? And where are we saving this here? So we have got data, we have got a container in which we are saving our databases. And third is the application program here through which we are going ahead and communicating with that container so that we can retrieve our data as we want. So three components will be coming here, right? Of course, here, what are the three components? First is, of course, data. You are importing data maybe from some SAP, maybe you are collecting from Google Forms, maybe some other forms or Excel sheets there. Or maybe your data is actually somewhere from an ERP system and you're trying to extract it from there. Or somewhere a website or APIs, you're trying to get your data here. Basically, you're trying to collect data from multiple sources right here. Now, to do all of those tasks here, you need hardware. You need hardware to make sure that you have somewhere to save that particular data. And then you need a software application to access that. So you can call them entities or components here, but this is what you need to create any kind of database there. Since we have got three different components here, we have got three different types of users based on the architecture of any database that is out there, right? I'm going to take you through a very simple one here. Okay, so every time, no matter where you see, for this, it is a layered architecture. Why I'm calling it layered architecture here? Because it is based on data abstraction. What is data abstraction here? Layered architecture means based on these three components here, please understand here that not everyone will work on all the three components. It is why? Because they are not going to give the access to each and every one to view in and out of everything. Okay, that's why it is always based on abstraction. So if there are exactly three components here, one person will be using the one component. Okay, they will not have the access to do something else. So they will be obstructed to view that particular data or view that particular side of the entire database. So on the basis of that obstruction here, okay, there are three types of users. The first user here is the end user. First user here is the end user. What does this end user want? This end user is only interested in accessing the data, creating the reports here, okay, use as minimal coding as possible. This is called as external view or application view here. So this is your third component where we are going ahead looking at the application program, the end view there, and we are simply using that to create reports, extracting data or accessing data that we want there. That person is an end user. Second person here is your application programmer or a developer, or right now we also call them data engineers, right? You also call them data engineers nowadays. What do they do here? They go ahead, they interact with the data here. They are the ones who will decide that the data is in the tabular structure. It should have common columns. It is having common columns. Their relationship is there, and the entire database is secured. Data types are properly given, all right, and plus it is optimized too to access it. So they are the ones who will take care of the entire application program at the backend. Plus, they are also responsible to get what kind of data should be stored, what kind of relationships should be there. They will go ahead and decide the schemas, databases, inside the logical structure of database that is called a schema. So they will go ahead, create a data model, and they create the entire structure of the multiple data tables that we're saving inside it. They are the ones responsible for this. This is why this is called as logical or conceptual level. This is why this is called as logical or conceptual level. Now, the third here is your best friend in your company. Third one here is your best friend in your company if you're working on any kind of research project there. Okay. Now, third person is your database administrator. Third person is your database administrator. Now, what does this DBA do? DB is the one, okay, that is responsible for maintaining the operability here. Meaning, this is the person who will go ahead and make sure that you are connected to the server properly. You have your access properly given. Okay, you have the permission to data set whatever you want permission with, and this person will be responsible for any kind of recovery, any kind of restriction has to be placed on you, meaning you should be given access to only the data that you are working with. If you're a finance person there, you will have the access only to finance data. If you're the person who are looking at the accounts, if you're the person looking at the HR, you will have only the access to the data which you're responsible for and nothing else. So this is decided by the DBA here. Usually in a proper setting of the corporate here, these three roles are properly defined separately. Okay. In some cases, if you go to a startup, okay, they might ask you to do everything that is out there. So everyone who is working out there, okay, if you are going for a business analyst or a data analyst, what do you supposed to do there? You are supposed to access the data, get that data into some software, and actually create the reports out of it, create the charts there, analyze what is happening in the business, know about that domain, and then go ahead and give that here. Right. The two here looks very fascinating right now, but this is the pure coding here. And this person should not know just one simple language. This person should know everything about the APIs. They should know how to work with any other system too. Okay, they should be well versed with Java, JavaScript. They should be well versed with C, C++ so that they can go ahead and use Python also if it meant to extract the data in a proper tabular format. So these people are the application programmer and the developer. You are not that. Right? They are not concerned with what is happening in the business now. They're only concerned with the data should be there. Are you that person whose work stops at, okay, my data is here, now I'm done? No, our work starts from there. Our work starts when we have the access to the data. After we have the data there, then we have to move forward and analyze the data and work forward with that. Okay, so we are the end users. Do we understand that? Do we understand this part here? That yes, we are the end users? No, right? So have you ever seen Google Forms? When you go ahead and look into the Google Forms here, okay, Google Forms suddenly give you some pie charts here and there, and it will give you the analysis as per itself, right? It gives you a little bit of ability right now to simply do some tweaks here and there, and that's it. Okay, so you are as an end user, you might have to work there, right? But it is not the end here. That's where you start your journey as a data analyst. So please understand here, as a data analyst, what you're supposed to do here. You're supposed to analyze its data set here. Okay, I almost discuss in every SQL here. Even though it is not related to SQL here, I still need to tell you this. And as a data analyst, what you're supposed to do. Once you have accessed the data set, right? First thing you should know that what is your objective. Step number one is always here. Step number one is always here to know the objective for the research or the analysis. Know the objective for the research or analysis. For example, okay, you're a branch manager for a bank, all right, and you get the call there from your manager, from the area manager. That's I want 5% increase in next quarter in the insurance sales. Go ahead and get it. Now you have to analyze it. That how I'm going to get the 5% there. So you have to first know the objective. So for example, they will ask you that to sell 5% more insurance in the next quarter, or maybe they want to figure it out here that why our assembly line is having too many defects in the end product. Figure out how to optimize the cost for a certain project, right? Or maybe go ahead and optimize the logistics out there. So you have to first know the objective that what you are supposed to do here. Once that is clear here, you go ahead and collect that what are the data tables here, which data tables you need, from where do you need that. Maybe you need customer data, maybe you need employee data or ship data from someone. You might need to ask access from DBA and they will provide you the data set with them. Or you may have to ask the data from some other department too. So it is all based on what is your objective. Once you have collected the entire data set here, you go ahead and you create a blueprint that what do you want to analyze. You'll figure out what is happening in this process, where it is happening, who is responsible, which particular process or part of the process is hampering it. Now you go and deep dive into it and figure out why is it happening. You see tendencies, trends, and patterns out there. You create graphs and reports out of that here. That is your step number 2. Okay. Now, after end, what is your step number 3 here? After step number 3 here, whatever reports you have built, you have to go ahead and represent the solutions. So whoever the decision makers are, right? All the business process managers, those are there. Directors, CEOs, BODs, whoever is the decision maker, you have to present your solution to them. And then they will select a solution and then you will run a test run of your solution. Again, you will collect the data. Again, you will analyze it. You will fix a solution. Then you will apply that solution to everywhere. And once you apply the solution to everywhere, you again can collect the data. You will see that how much effective was your solution. So this is a cyclical process. It will keep on going. Okay, so as a data analyst, this is your entire work. So this is what we're supposed to do. So SQL, where do we use it? Here. So this is the part here. Now talking about the RDBMS here, let's go ahead and figure out different types of databases, everyone. Let's see the types of databases that we have here. So we understood the file system, then we have understood about the DBMS, and now here we have what? RDBMS. So with the RDBMS here, it is in 2 parts here. So you see here we have got RDBMS, NoSQL database, and graph database, right? And these 3 databases here, Relational, NoSQL, and graph databases here, it is based on what type of data we are saving. Okay, these three are based on type of data we are saving, type of data that we are trying to save. And this distributed and centralized database here is that where are we saving? Where are we saving it? Basically, location. So let's understand them one by one here. So relational database, we are all aware. About the relational database here, we are all aware. That we have just seen it. Okay, there's a collection of data objects that are linked together by predefined relationships. Last in the RDBMS here, every data is connected to each other, and it is creating a proper logical structure there. It means we have got we can call we will be calling columns attributes here, and rows are called as records. And each attribute is going to have we are going to have common attributes, that is common columns here, that will establish the relationship among the data points there. Few examples here are, okay, MySQL, MySQL, PostgreSQL, and more. So PL SQL is also there. There are multiple examples for RDBMS here. And most of the time we are using RDBMS, right? Simple data set here, simple data set here, that is RDBMS here. Now, let's talk about NoSQL database. What is a NoSQL database here? NoSQL database is responsible here for saving are not a structured or unstructured database. What is unstructured database here? Meaning any type of geographical data with a lot of relationships or lot of hierarchy, or maybe you have images that you want to save there, okay, which in which they are in pixels or something. So whenever you have a data here, which is a non-tabular database, which cannot be saved inside a table only, in that case, no SQL is used here. So whenever your data is huge, it cannot be saved in a proper table there, we go ahead and we save that in the JSON documents. And instead of relational tables here, we'll have JSON documents here. What is JSON, everyone? That is Java Script Object Notation documents. Now, these documents here, they follow a certain notation. I will show you how does it look like. And there, they are going to simply save the key value and graph databases inside it. And it is very, no matter how huge your data is, the file size is going to be very, very small. And it is going to save your data in a very normal format. Now, these JSON files are really good when it comes to geographical data set here. What I meant by this. So for example, let's take an example here, okay? Let's take an example here. Have ever seen a geographical data set? A geographical data set? Let's go ahead and create one. So let's imagine here, we want to go ahead and list all the countries. A geographical data set there. And in this geographical database here, right, what we need, let's say we want all the countries there. So we need a column called as country. In front of country here, what we need, what we will go ahead, we need a states, what the states are inside it. And then here we will need cities that are inside it. Now, if I will go ahead and write the country A, for example, in front of the country A here, I will type the state here, right? I will go ahead and type the state for country is here, let's say A1. Done. Now let's say that country A has 50 states. It means that the country has to be repeated 50 times. Country name will be repeated 50 times because I have got 50 states here. We have got 50 states here. Now just imagine here, if each state here has, let's say, 100 cities, or let's say in a very nominal way here, let's say it has got 30 cities or 130 cities out there. So that many times country will be repeated, state also will be repeated. So simply save a hierarchical structure here, that inside this country, these many states are there and this city is there, we have to actually go ahead and save thousands and millions of rows there. And that to a lot of redundant data out there. So because of this reason here, we have got JSON documents, and JSON documents are very, very easy to save your data set here. So I will go ahead and open up a document here to show you out. But before I go ahead and show you a JSON document and how does it look like, okay, the major examples here, as you can see, MongoDB, Amazon, and HBase here. BSON is used. Great. But I think the objective remains same, that they are the non-tabular databases, Tanmay. Great. Thank you very much, Tanmay. So this is where we use it. So basically you're saving the databases in these kind of formats. Now comes the graph database here. Now what is a graph database? So for, okay, have you ever visited, you have seen LinkedIn and Facebook, right? So whenever you visit somebody's profile on the right hand side, they always tell you that people have visited these people also. Whoever has visited this profile, okay, they have visited these profiles also. Have you ever seen that in LinkedIn, Facebook, or anywhere else? Especially, I've seen that in LinkedIn a lot. Have you seen that before? Now, how do they know that? How do you think they are noticing that if you're going ahead and actually visiting a certain profile, right? If you are the person here, and how do you know that you're visiting a certain profile? And how they know that someone else has also visited that certain profile? And if they're visiting this profile here, if you are also visiting, someone else is also visiting this profile here, okay, they should go ahead and visit other profiles too. How do they know that? Do you think they can save that in a table structure? Do you think they can save this in a table structure format? The entire path that you're taking there, or anyone is taking there, whether your paths are getting crossed at a certain point, how do they know that? That's where comes the data graph database here. Basically, to figure out the social networking and recommendation systems here. So, for example, is this is you, okay, and this is some other person one, this is other person one, and you have been visiting multiple LinkedIn profiles there. This person and you have visited the same profile here, same profile here. Afterwards, okay, you went ahead and you looked for some other profiles back here. You went ahead, you went in a separate direction, you were looking at some other profiles, and this person is looking at other profiles here. Right. So now what will happen next? What they are going to do here, they are going to simply tell you that why don't you view these profiles? Why? Because this person has also seen this profile, but he went on to see these profiles. And to person one here, they will tell that why don't you see these profiles? Why? Because you came here and you went ahead in different direction and you were viewing the profile of these persons here. So basically, so they are simply tracking here, okay, and they are making sure that you understand what is happening there. So instead of saving that in a table, yes, it is going to create huge data records and very complex ones too. So instead of managing that here, okay, they will go ahead and use these graph structures or to store the data, where they're going to have notes, edges, attributes, and the parent-child kind of relationships out there. So these are the graph databases here. If you're interested in that, go ahead and read more about it. It is quite interesting that how do they actually build these systems at the back end and how they're saving that kind of options with us. It is quite interesting. Okay, go ahead and read about that. And this is your graph database there. So these are the three databases based on what kind of data we are saving inside it. Okay. Now we have centralized database and distributed database here. So what is centralized database here? Centralized database says that whatever database you have here, whatever hardware system you have, where you are saving your data ultimately, okay, it is maintained at a single location. It is maintained at a single location, such as mainframe computers. And physically also, it is going to be stay at one single location there. And if anyone wants to if anyone wants to access the database from anywhere, of course via LAN or WAN connection there, okay, they will simply connect with the one centralized database here. So most of the servers that we see here usually are centralized like this. Now, centralized is used a lot. Major banks here uses the centralized system, right? For example, whatever users they are getting fetching the data here, they save the entire customer transactions in one central server. Even the airlines reservation systems, the few are out there, they save in one single, they will go ahead and save that in one single server at one single location. Even whatever ERP system or SAP systems we have there, right? They will all for especially created for the enterprises, that is also saving entire data in one single place. So most of the time, okay, we are using these centrally. But yes, these are the disadvantages right here. Now, what is the distributed database here? What is the distributed database here? Distributed database is it is just opposite to centralized here, right? What what we will do here in distributed database? In distributed database here, okay, it says that you're going to have databases at several different locations, here. However, okay, it is going to have the unified collection of linked databases, meaning even though databases are saved at multiple different locations here, they're still going to be linked to each other. They're still going to be linked to each other. So it will form a distributed database. They will be logically interconnected, but physically they will be distributed over several sites. Now, whoever wants to access this here, from the multiple locations here, okay, they can access wherever the data set is. So maybe they are accessing the data set from here. Okay, they want to access data from here, and likewise. Now, what are the advantages here? So first thing is there is no single failure point. Your data is properly distributed across the multiple locations. Sometimes it can be slower if you're getting data from everywhere. It can be slower there, but yes, it is quite expensive to maintain. Yes. Let's say the hardware will be distributed here. They can be at multiple locations physically. So that location can be geographic locations there, of course, and they will be on entirely different hardware systems too. But they will be interconnected there. So these are the few basic differences between centralized and decentralized here. And failure risk is very low in decentralized here. In centralized, it is going to be higher. Okay, decentralized might be slower. Why? Because we do not have a local access to it. So data locality is in the centralized database there, because locally it is available at one single access. However, when it is at the decentralized database, it is a little bit slower than the centralized database because you're getting data from the multiple locations at once. Okay, so in these cases here, decentralized will happen. Usually the Google Cloud that we have here, okay, they use the distributed database, and across the data centers, they actually distribute the database there. And there are MNCs also there, okay, they use the local databases for operation, but they use local databases. For example, if I have an office in Bangalore, their database will stay there. If another office is at Mumbai, their data will stay there. So once the corporate wants to analyze that data set or get that data set there, they will simply have different data centers. They have to go ahead and get their database from the different data centers too. But yes, they will be logically interconnected. So yes, that happens. And that is your distributed database. So geographically also, they will be at several different places. So these are the different systems, everyone. So let's try to answer this here. Which system is characterized by having its data structured, logically interconnected, and physically distributed over several sites within one computer network? Which one do you think it is? Yes, it is. It is in the question itself. They see the distributed database system here. Distributed database system is unique. Okay, it involves multiple linked databases which are physically dispersed across different locations within a computer network. Right? It still remain interconnected and structured. It can enable efficient data management and retrieval across diverse geographical locations. Right? Now here, what is SQL and what are we going to work on? So when we are talking about, yes, very good. Thank you very much for the answers and the participation, everyone. Thank you very much. Now let's go ahead and understand here. We understand what databases, how we are collecting everything and why we are doing that here. But when we say that I want to access the data here, that's where we need SQL as a language. Now, what is SQL here? SQL here is a structured query language, right? So let's divide it by, everyone. Let's divide it by. So we have got a structured, right? And then we have got query and the language. What is language? Medium of communication. Yes, very good. It's a means of communication. With whom we want to communicate in this case? We want to communicate with the machine. We want to communicate with the machine because machine contains the data. So I want to ask to the machine there that, can you give me my data? That's it. The system that we have developed, the application that we have developed there. We want to talk with that particular database specifically, the container that is holding all the data set. So what is it? So we have to use a language there. So it's a language. Now, what kind of language it is? It is a query language. What kind of language it is? It is a query language. What is meant by the term query here? What is meant by query here? That we're asking a question, right? We're asking a question there. We are querying something out. So this particular language is simply meant for asking the questions to the database. It is not a programming language. Programming language is the one where you create something. Okay, from when something doesn't exist, you create out of nothing. So we are not creating anything there. We are not developing an application here. Absolutely not. We are simply communicating to the application. Let's say I wanted to create this. Can you give me this? Can you give me that? So basically, we are simply requesting, yes, data or information here. So we are simply going to request that data information here. We are simply going to ask questions. But since we want to ask questions and it's a language here, right? It has to be structured. It will have its own grammar. It will have its own rules and regulations and certain keywords and letters that it should be using there. Okay. That is why it is called as a structured query language. So it's a language through which we ask questions to the system. But since it's a language, it will have its own rules there. Okay. And this particular system here, it allows for any specific data query that we want to extract, right? Through this function here, we can go ahead and we can create, read, update, or delete. What does that mean here? Meaning we can go ahead and we can create databases, we can create tables out there, and we can read or extract whatever we need. We can update whatever already exists. Maybe I want to update my data set. Maybe I want to update more columns inside it, maybe rows inside it. Multiple different kind of updates can be done inside existing table here. Plus, maybe we want to simply go ahead and delete whatever we want here. So these are the 4 type of operations that can be performed by using SQL. Now in SQL here, we have learned about here RDBMS, right? So what we will be using there, we will be using a MySQL there. So the lab that we have available, right? That lab is going to access the MySQL for us. Why are we using MySQL here? Because it is a very specific software product. It implements the functions of database server, and it is the most fundamental and easiest tool to learn SQL. Okay, whatever we are going to work here, whatever we are going to work within it, it will be almost, you will find the commands, the concept almost everywhere else, right? So that is MySQL that we are going to use here. Now we are seeing that our this MySQL here is RDBMS, meaning this is the Relational Database Management System. This relational database management system here, it is the most popular one right now. Even though we have big data, not everyone has the big data. They are still using the RDBMS here. So what is RDBMS here? In the RDBMS here, okay, we will have here. So what will be the RDBMS here? Okay, in the RDBMS here, you have multiple data tables. Okay, you will have multiple data tables here. And all these data tables will be interconnected to each other based on common columns, Okay, so that's how it works. So that is RDBMS here, Relational Database Management System. Okay, so that's how it works. All right, great, thank you. So if that is RDBMS, everyone. Okay, a few examples are these. This is just the advanced version of there. And then now we have, wait. Right. Now, what is the difference between DBMS and RDBMS here? DBMS here, it stores data as a file, a single file here. RDBMS, we do have multiple data files there. What are the differences here? It stores data which is not related to each other. These are the standalone tables. These are the tables which are connected there with the foreign keys, or they will have their primary keys and foreign keys there, meaning basically the common columns here. In DBMS, if we want data from multiple tables, it is going to be slower and complex because the data volume is huge. In RDBMS, your data tables are smaller and interconnected. It will be easier and faster than DBMS. Next here is, okay, RDBMS, of course, without normalization, we are not going to have any kind of keys or common columns there. So RDBMS will have the normalization. We'll see what normalization is. And it has got multiple levels of security here. DBMS doesn't. And it has got absolutely no security. So what are the examples of DBMS here? Okay, any kind of file system we have in our particular drive, which is a let's say a shared drive among the entire department there, any kind of XML file or XS file there, right? So these are the files that people can access. They can access it. Okay, understand that, Yogesh? They can actually access, multiple people can access that file there. But if they are making the changes simultaneously, okay, DBMS might not be able to isolate the transaction. So for example, there 10 new people have joined. Okay. And there were two HR executives, those who have been given the responsibility to update the data there. They didn't communicate it well, and both of them updated the data inside. So let's say the executive one has updated the data at 11 a.m. at 11 a.m. and the executive two has updated the data at 1300 hours. So this is how it works. This is how it works because there is absolutely nothing there it can do. So that is your DBMS and RDBMS and everyone. This is the difference between them. Now we will talk about RDBMS and we will only work with the MySQL here. Of course, the MySQL here needs workbench. It also needs uh, the server there. So we will always be working with two things there. One is going to be the server, one is going to be the workbench. Workbench will be the one where we will go ahead and type down what we are looking for. And let's talk about what about the database or RDBMS right now. That is very, very important here and why we are working on that. So first thing is we need server and the workbench. Workbench is the interface, end user interface or GUI there through which we can interact with the server at the backend. Now everything will be given to you on the lab. We will see what is that after the break. So what is a database here? Technically, if we talk about, it is a well-organized digital storage system, right? That allows us to store, manage, and retrieve data efficiently. Now, MySQL here, we are going to use MySQL, all right? So MySQL here, in MySQL, the term schema and database are synonymous. And they can be used interchangeably. And this happens in MySQL only. Okay, otherwise the schema is the logical structure of your table. Okay, basically we call it an ER diagram or entity relationship diagram. That is the logical structure at the backend. And database is the physical entity or in which we will go ahead and save that schema. Okay, however, in MySQL, whether it use the term schema or database, they are going to be synonyms. Always remember that here. Second here is it follows a certain quality. Okay, these are called as that any database that is a good database. How do we decide that? We decided with the asset properties here. Now, what are these asset properties here? And why this is atomicity, consistency, isolation, and durability. Now, let's understand them one by one. First here is atomicity. What is atomicity here? Okay, atomicity here is that whatever transaction we are doing, it has to be completed. Whatever transaction we are doing here, it has to be completed. Meaning, if any part of the transaction fails, right, it should be considered the entire failure and we should roll back everything else. Meaning, we should undo that change immediately and it should go back to the original manner only. So it is all or nothing. What is atomicity here? It is all or nothing. All or nothing simply means that you can, for example, here, let's take a very simple example to understand these terms around here. Let's say we are doing some banking transaction, right? And this happens to a lot of us whenever we are using any kind of UPI or transaction there, that your transaction fails. What happens when your transaction fails? Do you get the message that your transaction has been failed? Does money leave your account or not? As soon as you get the message that your transaction has failed, did your money actually left your account? No. Why that didn't happen? It didn't happen here because of the atomicity, because whichever a good database here will make sure that if any transaction fails, right, the entire transaction should be reversed. No database here is left in the half done state. So if any part fails, we simply go ahead and roll it back, right? So that is atomicity. Now, the second is consistency. What is consistency here? Consistency means that database should always be in a valid state before or after a transaction. Okay, what does that mean here? It simply means that, for example, if you want to go ahead and you want to go ahead and transfer 10,000 to someone, it means that your account should have 10,000 in your account. So any amount that you want to transfer to someone, all right, any kind of amount you want to transfer to someone, you have to make sure that amount is in your system right now, in your account. You cannot have zero balance, and you cannot go ahead, even having the zero balance, you will not be allowed to simply go ahead and transfer 500 there. Right, that is consistency. Consistency is it will maintain a transaction and it will follow a certain set of rules. That, see, if I want to go ahead and save date should be in a proper format. If date is in a proper format, then I will be able to extract the year-wise transactions out there. Yes. So that is consistency, right? So it is simply maintaining a simple transaction right here. So it is solely concerned, okay, that when whatever happens during the transaction there, whatever happens during the transaction, it always follow a set of rules. So if I'm updating my date column, for example, so that should be before also it should be a date column. After we go ahead, it should still be a date column. All right. Basically, if you know about the term constraints there, your constraints are the rules that we place on the databases while creating them. Those constraints should match. The business logic should match, right? So that is consistency. After consistency here, we have isolation. What is isolation here? Isolation means that your transactions should not clash. Your transactions should be isolated. I will give you a very simple example here. Okay. You all have booked movie tickets online. You all have booked movie tickets online, airplane tickets online, and you have selected your seats there. Now, this happens rarely, but it happens. Okay, sometimes two people can book same seat. How many times do you think has happened that two people have booked the same seat on the same flight? That is isolation. It means that if there are multiple transactions going on together, right, each transaction should be taken as an isolated incident. And accordingly, your database should be updated. If that is not done, and the transactions are actually overlapping with each other here, it will be very difficult to actually get any kind of data set there. So to prevent conflicts, okay, isolation ensures that the one transaction finishes before the other affects the same data. So if multiple people are booking the seat at exactly that minute, okay, you will be still there with the, they will make sure that you are actually booking one after another at the back end. They will make sure that you are booking one after another only. On what basis, what rules they will apply, that depends on them. But they will ensure that the transaction should not affect each other at all. Now, the last one here is durability. Durability is simple. Okay, we want to guarantee there that whatever data we have here, it should not be lost. It should not be lost. So data should always stay safe. So for example, let's say, okay, they have decided that we want to go ahead and delete our data set. So if I want to go ahead and delete an entire table from there, and once I will successfully commit that, okay, then that particular transaction should not be lost. Even if the system crashes and we get the system back, that transaction should still be safe. Okay, now let's understand this here. Okay, it does that ever happen to you that you have completed the entire shopping online? Okay, you paid everything, and then your system crashes and website crashes there, and it shows you error. But when you go back to your email ID or your SMS there, your transaction has already passed through. Your order is already placed. So there was nothing happened to your order. However, the moment you paid, the entire system and the web page has crashed. But when you go back, right, just after making the payment, but when you go back to your email IDs, they will tell you that no, your order is already placed and you are good. Your payment has been received, your order has been placed, you'll get your order in these many days. That is durability. That is durability. That web page crashed. You are not able to see your order right then and there, but you have committed the order, right? It means that even if the system has crashed, it must remain saved. So key terms here are commit and right ahead login, meaning we are permanently saving any transaction that we are doing there. So even if it crashes, their data will remain safe forever, right? So those are the asset properties of database, everyone. Right now, before we go ahead and learn about anything else, okay, we will go ahead and see that what are different type of commands that we have here, and how and when we are going to use that. And I will go ahead and learn about different type of commands that we are going to work with. Now, let's understand here about SQL. Now, we will go ahead and look at the technical part of it. Let's see, we have understood one thing about it, that it performs the four operations, that is CRUD, right? Meaning we are going ahead and we are creating something. It means we are creating a database or a table or inserting the database and creating that here. Yes, we can verify that. But we should know commands first to check whether that property actually works in that or not. Okay, we have to first check, we should know the proper SQL commands first. So we know the commands and how do they work, then we will be able to check that. Those who already know about it, right? For you, it is easier, but it is not easier for for I think 60% of the class, which is for them, it is very, very new. Okay. So let's see, learn technicality, everyone first. Thank you, Radha Prasad. Thank you there. First, let's go ahead and learn about the commands, basic commands, right? And then when the time will come during the end of when we have seen all the commands, clauses, operators out there, right? Then we'll go ahead and we'll see that how do we verify the asset properties in our database. Okay. Here is, let's go ahead and see create, read, update, and delete. Now remember that these are the actions we are talking about. What are these? These are the actions we are talking about. It is not talking about the types of commands. But to carry on these sections, okay, how about now? Am I audible right now, Ritushna? What about others? Am I properly audible? All right, great. Thank you. Okay, great. Thank you very much. So these are the actions, everyone. These are the actions that we can perform. But to perform these actions here, we need commands, right? We need commands here. So here are the four types of commands, as you can see. That is DDL, DML, DCL, and TCL. What is DDL here? DDL here is data definition language. Data definition language here. What we are defining here, we are defining the table or a database. So we are here trying to create a database here, or alter the table structure, or drop the table or a column, or we simply want to truncate it or rename a table or rename a column. So this is here data definition language where we work on the table structure and the database structure here. After DDL here, we have got DML. What is M here? M is manipulation. M is manipulation. When we are talking about manipulation here, we are going to talk about that while here we are inserting the data set, right? We are selecting data set. While selecting, I might want to filter it out. I might want to add some calculated column in that. Okay. Or I might want to sort that table out while extracting that. So we are kind of manipulating the data set here. So we can select the data from there. We can insert the data. We can update existing rows of the data, or we can go ahead and delete the rows of the data set. That is data manipulation language. Next here is DCL and TCL. What is DCL? Yes, data control language. So this is data, that is language, that is done. So it is data control language. And then what is TCL then? So here C is still controlled by CRC is also it stands for control here, but now it is controlling the transaction. Now it is controlling the transaction. So this is data control, everyone, and this is transaction control. So what is data control here? Data control here is we are simply controlling the permissions. What we are controlling here, we are controlling the permissions and the access. We are controlling the permissions and the access to certain database or data tables. So either we are granting the permission, we are revoking the permission. So we are creating the users. So in the DCL here, we will be creating the users out there. We were granting them the permission, giving access to certain databases and a lot more. So who does this? Which user does this part? And we have transactional control here. What is transactional control here? Transactional control here is that if I want to go ahead, okay, and insert a new data set. So this month, let's say new customers have subscribed our application. So I want to go ahead and insert the new customer data. Of course, in the existing data, in the existing data table, in the existing data table here. So while I'm inserting the new customer data here in the existing data table, I have to go ahead and abide by the rules and everything, right? So I'm updating here. We have got the entire team who is extracting and inserting the entire new customer data into our database and pushing that data there. So while I'm doing any kind of transaction, I'm altering the table structure, I'm inserting the data there, I'm deleting something out there, or I'm simply updating something inside it, or adding more columns inside it as per the need there, making any changes there, that is called as transaction. Because right now you're transacting with the database. You're giving some data there, or you're taking some data set out, meaning permanently making the change inside the database. So in that case here, you get to either commit the change, roll back the change, meaning undo the change, or save up to that point, and later on you can decide whether you want to roll back or you want to commit. Commit means permanently saving it. Roll back means undoing the change there. Save point means just save till here and don't change it permanently. Just save the changes till here. So this is transactional control. Basically, we are transacting within the database with the data that we are controlling with. Who takes care of this part? Managing the data inside the database. Does this part? Are we supposed to interact with database? These are the developers. These are the developers or data engineers or application programmers, those who are supposed to bring data from multiple sources here and make the changes there. And in some cases, DBA will also do this part. In some cases, in very few cases. Right. Okay, in very few cases, admin people will be there. Okay, though will be separately working as a data engineer and working with the database there. So what is our focus is going to be? Our focus is going to be these two. Our focus is going to be these two here. DDL and DML. Now to talk about DDL and DML here, right? So can you tell me which of these comes under the DML command? Data manipulation language. This is our DML, everyone. This is our DML. Select, insert, update, delete. So what falls inside it? Okay, DML here, our purpose is to manipulate and interact with the data that is already stored in the database. So what is data manipulation language here? The only purpose of that is to manipulate and interact with the data that is already stored in the database. So we are going to select it, insert it, or delete it there. So which of the following commands are we using here? Select, insert, update, delete. What is available here? Select. So first, I am going to talk about DML here. Let's talk about DML first, then we'll talk about the DDL. Now in DML here, we say that it is about inserting, updating, and deleting databases here. It primarily consists of retrieving, inserting, and updating and deleting the dataset, right? So we will go ahead and understand about these options here. First, we are going to start with, of course, select the statements. But before we see the select the statements here, we will also have to understand about DDL, because unless we don't have a table there or a database there, we cannot simply go ahead and create it. We are going through the MySQL workbench here. And now first let's go through the interface here. And now we will be able to smoothly work within the SQL and learning process through. So right now, as here, you will have 4 quadrants, everyone. You will all have the 4 quadrants here. So as you can see right now, You will have query 1 written here. Yes. And we'll go one by one, step by step. Step number 1, left and upper corner, everyone. You will see 2 tabs are there, right? One is home tab, one is local instance tab here. We can switch between them. So if you click on the home tab, you will go to the home tab. If you come back here, you will see the local instance tab here. Just below this, you will find your menu card system, that is file, edit, and view. Why these are all menu drop downs, file, edit, menu here. These are all menu drop downs here. So in the file drop down, edit, view, you will see all the options right here. Below this file menu drop down here, you will see quick access toolbar. In this quick access toolbar here, we have exactly the similar ones, but these are the ones that are used frequently. Okay, these icons here or features or functions, these are used frequently here. Now below this here, okay, this is our navigator window. This is our navigator window. Currently in this navigator window, you are able to see all these options here, management, instance, performance, right? I would like all of you to go ahead and look here. Right now you are in administration. Right now you are in administration here, but there is one more option called as schemas. So within the navigator window here, we have got 2 options. One is administration, another is schemas. So go to the right side of the administration there and click on schemas, please. So once we click on schemas here, we are able to see here SYS. This is our simple database, right? It's a simple database here. Whatever system, yes, it's a system database here. So right now, whatever databases we have here, it will be written here. So this is the schemas window. Now we are here. And now here you have query 1. What is this query 1 here? Here we get to write our script. Then we go ahead and we get to write our script. And this is the help section as it is written here. Whatever we use here, the help started appearing here. Below this here, we have got output window. In this output window, whatever query we are going to execute there, okay, it will tell us what is the date and time there, what was the action we performed, is there an error or it was executed properly, and how much duration did it took to fetch the answer. And from here, okay, you can get any object if you're using or the session details here. You'll have your session details here. So if you're not connected to the server, it will be red in color and giving you a message your server is not connected. If you're connected properly, you can see your port, login user, and all that details around here. Okay. Now here on the right hand upper corner, of course, it is not a very huge space to type anything here. So on the right hand upper corner, you must be looking at 3 squares right now. You must be looking at 3 squares here on right hand upper corner here. With the help of these 3 squares here, you can switch on and off your help section. You can switch on and off your output section. You can switch on and off your schema section, right? So this also depends on us. Now in the query here, in this query 1 here, do you see we again have some toolbars here? We again have some toolbars here, right? So in this here, first thing that we do is let's save this query as day 1. So here is the save button, everyone. Control S also works. So if you click on this save here, this gets saved as day 1. And with simple control and what do we call this? This is scroll bar, right? With simple control and scroll here, we can zoom in and zoom out to increase the font size here or decrease the font size here. Before we go ahead and start typing and practicing here, there are a few things about typing here that we should be aware about. So let's go ahead. And now here, first thing I would like to remind you here, whether we use the term database here or schema, whether we use the term database here or schema, both are synonyms in MySQL. Both are synonyms in MySQL. So it doesn't matter which term do we use here. Now, why I'm typing this pound sign here? Okay, it means that this is a comment. Okay, this is a comment. What kind of comment it is? It is used here to write a single line comments. Single line comment. To write a single line comment, we can also use hashtags and the space here. We have seen that yesterday, right? This is also used for the single line comments here. What are comments, everyone? Comments are the non-executable parts. It basically, we will go ahead and we will write the descriptions about it. We will write the description of the codes or any message that we want to give there. The 2 lines here. What if I have a huge comment to write? To go ahead and write a multi-line comment here, we go with the forward and asterisk here. and we get to type the multi-line comment here. How do we end a multi-line comment right now? So multi-line comments are enclosed with asterisk and the forward sign again. And when you have multi-line comments here, you see this minus and plus. Okay. So these all are comments. Now we will go ahead and we need to get our schema. We need to go ahead and get the schema here, everyone. And in that schema here, we will do 4 applications here. Either we are going to create something, or we are going to read it, or we are going to update it or delete it. So these are the 4 options that we are about to see. First, let's go ahead and understand about create here. In the create here, first thing we should know how many data types SQL can handle. If we understand that, it will help us to, it will help with a better understanding of the data base that we will extract right now here. So we will see how many data types SQL can handle and how we should be reading that there. To check out the data types in SQL, well, how many types of data types we usually have in general? Types of data variable. No, data types in a table. What are the basic data types in a table? So there are 3 majors There are 3 major ones, right? What are the major ones here? The first one here is character. You can also call this text. You can also call this string, right? What is the second one here? Second one is your numbers. Numbers. What is the third one here? What is the third one here? There is third one also, other than character numbers. Date. Date. Very good. Date. Boolean is also there. Boolean is there. But the major with these are here. Date. So let's see these 3 first here. So let's talk about the characters in SQL. So what are the characters here in SQL here? The first one here you will find is car. So what is a car here? It's a fixed length character. It's a fixed length character. What is meant by fixed length character here? Fixed length character means that, for example, I have got any kind of IDs here, or any kind of a student ID or codes or keys given to something, right? So when you are giving any column a character here, it means that in every row, there, okay, we are going to have exact same length of the characters there. In this case, we use the char. Second one here is the wildcard. Okay, we are using here everyone. We are going ahead and I'm simply giving you the description about whatever we generally use. Wildcard, as the name suggests, it's a variable character. Variable character means the length is variable. Variable length here. What is meant by variable length? It means that if we are going ahead and writing somebody's name, person's name, employee name, country name, city name, or product name, department name, whenever you're writing name of something or anything here, okay, in that case, every record that we have inside that column, it is going to have multiple variable length, right? Of course, we can go ahead and we can define the maximum length there. So after wildcard here, okay, we get to define the maximum length. So that what is the maximum character length that we have here? So we get to define that in character and see a car and wildcard. Car and wildcard. That is there. These are the simple ones here. Char and varchar. Of course, we do have more here. These are the most used ones there. Let's talk about the numbers here. Or you can call them numeric. You can call them numeric here. So these numeric variables here, in here, the first one here in numbers, first is integer. What's an integer, everyone? Integer here is a whole number. Whole number, for example, number of cars, number of employees, number of classes we have, number of branches, number of departments. So it is always going to be a whole number. Other than whole number here, we have got float. Float is sometimes also called as double. Float is sometimes also called as double. With the float here, we do have decimal. We do have decimal, and yes, both are different. So with float and double here, what is float or double? Okay, huge number with decimals, so a big number with decimal points. Or you can call this as that it's a fractional number. Okay. What is decimal? Decimal also contains the number with decimal or fractions. And then what is the difference between the two? Now let's understand the difference between that here. Float and float or double here. Okay. Any the kind of numbers or the columns where we are using float there. Okay. We can go ahead and round that number off. We are allowed to do that in that float here. Meaning, for example, I'm doing any kind of a statistical calculation. I've calculated average of something. I have multiplied two numbers, and then I have calculated their standard deviation or maybe the variance of that. Okay. So in or median calculation or mode calculation I'm doing. So if I'm doing any kind of statistical calculation there and I'm having a huge number, and when I round it off there, it will not make any difference there. That is float. Okay. But what is decimal here? Decimal number here, we cannot round it off because rounding it off will actually impact your data. It will actually impact your data. For example, if you're working in accounts, right? In accounts, you're going to go ahead and calculate somebody's compensation there. So you cannot round off that compensation. If you're calculating some economic number there or economic KPI there, you cannot simply round it off. You have to be with precision. You have to write that these many decimal points are there, and it means that. So any kind of scientific calculation, any kind of calculation related to finance or economics, you cannot round that thing off. So that's where the decimal comes in. So if you're talking about finance or salary there, okay, you don't round off your numbers there. You use the precision. You use that precision there. We cannot compromise that. So this is how it works. So this is your integer, float, and double. Other than that, other than this here, we do have big integer, small integer, medium, tiny integer, and a lot more. So like this here, we do have more. We do have more. But these are the few that are used most here. So we can go ahead and decide, okay, how much accuracy we require at any numeric number that while creating your data. Remember that while creating that data table, we define the data type. Now let's come to date here. This is not only date, everyone. This is date time because it consists of date and time both. So in this date time here, first is of course date. After date here, we have got time. After date here, we have time here. After time, we have date and time together. Yes, we can get date and time together. Then we have got time stamp. We have got time stamp there. After time stamp here, we also have year separately. We have year separately here. So let's talk about when we talk about date or time stamp here, what is the format? In MySQL here, the date format is fixed, everyone. Date format will go from by MD, meaning first you should have year, then month, and then date. If we are not following up this format of your database is not following this format there, it is going to go ahead and not recognize that column as a date. So we have to go ahead and format it separately so that it can follow along with this part here. We can also go ahead and write it without without the hyphens here. It will still follow it can still go ahead and recognize your date format. Years are also recognized. Years can be 2-digit or 4-digit format, and both are recognized here. Right. Now, let's see here. Right now, we don't have any databases in here because we have just started right now. So let's see here. Let's see here how we can get databases here, right? How we can get databases here. So there are three ways. Okay, three ways to get database. What are those three ways here? Those three ways here. First one is we can go ahead and create it by ourselves. Three ways here are, first here we can go ahead and create it by ourselves. So we can create a database, and inside the database we can keep creating the tables and insert the values there, right? Or we can go ahead and import the data. We have already seen the import data from yesterday, right? Very good. We can import the data also here. or we can simply use the pre-existing database and we can open it here. We can use the pre-existing database here. So how do we go ahead and utilize the pre-existing database here? A pre-existing .sql file, pre-existing .sql file, already written file there. So we'll see. We know how to create a database. We created that yesterday, but let's go ahead and create it again because now we have this in our own systems right now. So we can type create database. I'm going to give this name as IIT DB and here. Now remember that what is this semicolon here? The semicolon here tells us about terminates terminates the statement. It means this is the statement. And this is only what we want to give the instructions here. So we terminate the statement here. So basically we're informing that this is where the statement ends. And this is what I want to do. This is, yes, end of the line. So we are simply telling it that, see, this is where it ends. And this is the first instruction I want you to follow along. So that's what we're giving there. Now, how do we execute the statement? To execute the statement here, either you can go ahead and press Control Enter, okay? Or you can use those lightning bolts that we have here. About these lightning bolts here, there are two types of lightning bolts, everyone. There are two types here, right? What are those two types here? First is the simple lightning bolt on the left side. One is the bolt with the cursor, right? So here you have got bolt. Another you have got bolt with cursor, bolt with cursor. Now let's see the difference between these. So first one here is, this one here is, it is going to execute the entire thing if there is no selection. It means this can go ahead, this bolt can go ahead, and if you have multiple statements there, it can go ahead and execute multiple statements at once. Multiple statements without selection, multiple statements at once, of whatever you have selected, whatever you have selected. And the bolt here with the cursor, it can, even if you're selecting multiple statements, it can go ahead and execute only single command, single command or statement. So you don't have to select anything. You have to simply keep the cursor there and Control Enter. That is bolt with the cursor there and it will work. Where is it written? I'm not saying here. Go to query drop down. Go to query drop down and see. Execute all, Control Shift Enter. Execute current statement, Control Enter. Okay. So if you go to the query drop down, you can see it right here. All right. So let's go ahead and create the database, everyone. I'm going to select this here, execute this here, but I don't see database. I don't see the database here, but as soon as we go ahead and refresh it, we get the database here. Once you see the database, everyone, you can simply go ahead and expand it. And you can see an empty database right now. Now, once you have .sql saved properly in your system, please let me know. The file name is mysampledatabase.sql. We are going to import that file here. To import that file here, okay, we can either click on this folder here, or we can go to the File tab and click on Open here. So if you will go to File tab and click on Open SQL script here, right? Open SQL script here. All right, now follow along with me, please, everyone. Okay, whether you go to File drop down or you click on Open SQL script, or you simply go ahead and click on this folder here. You will see this right now. Now from here, you can go ahead and get your MySQL sample database, wherever it is. So go ahead and get the MySQL sample database. You will easily find the .sql file. Please click in here and click open here. Everyone, go ahead and click open there. Do you see MySQL sample database here? Multiple lines are here. So table script is already written here. As you see this table script here, do we see this table script here? As you can see the annotation right now, everyone, go ahead and click on the first lightning bolt. It is going to go ahead and execute the entire script. Once the execution is done in next 4 minutes, 4-5 seconds, click on refresh. Once you will click on refresh here, you will be able to see classic models. And when you expand the tables inside it, You can see the list of tables here. Once you can see the list of tables here, so first here is, we are going to go ahead and start with the read query here. It means we will start with the simple select query, everyone, which comes inside the DQL. So from the CRUD here, we start with read and select query DQL here, right? So first thing here, how do we go ahead and select anything here? So for example, we want to view customers table here. So how do we go ahead and give the table reference that which table I want to view? Before we go ahead and understand the table reference here, let's understand the how the tables are located. So as you can see in the schemas right now, first we have got database. Inside the database, we have got tables. If I go ahead and expand the customers table here, you will find that inside the table here, now we have got columns. And if I expand the columns here, can see the column names are all here listed out. So if I want to see the entire table here, we have to go ahead and give the entire location, meaning we have to go ahead and say that, go to this particular database or schema, go to the schema here or database name here, and then we have to type a dot here and get the table name there. That's how we have to give the entire location here. Now to give the location here, we use the select query, right? How does the select query works here? In the select query here, we go ahead and we write select first, select. Now in the select here, we have two choices. Either we can go ahead and define the column names, that these are the columns I need to see from a certain table. Or if we want to see all the columns there, okay, we can go ahead and type the asterisk there. We can go ahead and type asterisk sign there. Asterisk means I need all the columns. That's it. All the columns are good. So we can go ahead and we can get all the columns there. So for all the columns here, we go ahead and we type asterisk, right? So we need these things here. Now we have to go ahead and define from. So after select is written, now we will go ahead and type from here. In the from here, we go ahead and we give the location here. What is the location here? That inside a certain schema, there is a certain table that I want you to go to and pick up these columns from there. So this is the certain syntax, everyone, right? So let's go ahead and write the syntax here. So right now we are going to fetch the whole table. We are going to go ahead and get the whole table here. To get the whole table here, this is how we get it. So select everything from classic models. I'm selecting the database here. I'm putting down a dot here or period and see what I'm getting, the list of tables. Right now I want to see customers here. I'm selecting customers. And then we terminate the statement here. After terminating the statement here, either we can click on this or we can press Control Enter. And here we see. What is this here? This is the result grid. What is the result grid here? This result grid here, everyone, it is your temporary output. And in this temporary output here, you get to export your file from here. So we will move forward right now. Now, and let me please tell you here how we are going to practice it. Right now, what we have seen, we have already selected the entire table. So we have the entire table here. We have the horizontal bar. We have got the vertical bar here. If we look at the output right now, look at the output here. We have 122 rows, meaning the customers table right now have 122 rows here. Great, wonderful. What if I don't want to see all the columns here, right? I want to see select few columns here. So here I will go ahead. I'm going to copy paste the entire thing same as it is. I'm copying pasting exactly same thing here. However, instead of asterisk here, now I will go ahead and type the column name. But I don't want to type the column name here. Why? Because it can be case sensitive. I can make manual mistakes here. So instead of typing down the name of the column here, we will simply go ahead and double click on that column name. Just double click, everyone. So after select copy paste here, when the cursor is blinking here, I'm double click here and see I've got customer number. If I go ahead, okay, if I go ahead and type a single column, here and execute this line right now, you can see I'm getting only one line here. Correct? In the similar manner here, we can go ahead and get multiple lines too. We can go ahead and get multiple columns too. How do we get multiple columns here? So since I already have the single column here, I can go ahead, type a comma here, and double click again to whatever we want. Maybe I want customer name, customer number, country here. So just type a comma and get the another here. Type a comma and we have credit limit. Let's get that too. Simple, right? So like this, we can go ahead and get the multiple columns here. If I now go ahead and execute this, how do we execute this? Either you select and control enter, or you can simply keep your cursor inside and click on this bolt here. And see, now I only have 4 columns here. Few things that you should know here, okay, command or that we are typing here, or the keywords that we are typing here, they are not case sensitive, but the name of the columns are case sensitive. Okay, so the commands and queries that we type here, commands or keywords we type here, okay, or the clauses that we are going to type here, those are not case sensitive. But if you are selecting anything else here, that is case sensitive. All right, so here let's move forward right now. Now we understand how to simply get a table there and how to go ahead and select few columns here. Now let's understand something about the select query, everyone. Now in the select query here, we get to go ahead and select columns and attributes. We can call them columns or attributes here. Other than that here, eh, it is not a programming language. And each statement is a separate statement, Tarif. Okay, it is not a VBA code or it is not a VBA code that if my script is start with the sub script or sub process, sub procedure. So entire thing is sub procedure. No, each statement is a separate statement. And while you are trying to extract something, the script will start from select. When you are trying to update something, script will or the command will start with update. If you're creating something, it starts with create. Right? So when we are retrieving something, on that part, you're absolutely correct that it will start from select always. So let's look at the writing sequence, everyone. In the writing sequence here, okay, we get the select and we select with these columns here. We select columns and attributes right now. Within the select statement here, we also get to go ahead and do the aggregate calculations, meaning by doing these aggregate calculations here, we also get to add calculated columns. These calculated columns can be added by simple mathematical calculations or logical calculations. After select, we go ahead and we type from here. What is from will do? From will simply tell us about the location or the address where the columns are. Because I want to select columns in a table, and from will give us the location that where the tables are. Generally, where the tables are always inside a table or inside a schema name. So instead of writing table here, we have to first give it a name of database. And go inside this database and now go ahead and get the table. Inside the table, we'll find the columns. After from here, we have got where. Because every time I don't want each and everything out there, right? Instead of that, I might want only data from USA. Maybe we are looking for the persons who have credit limit of more than 75K, largest spenders out there, right? So we can go ahead and we can give multiple filters or conditions on the rows by using the where clause. After the where clause here, we will have group by. What is a group by here? Group by here will help us to create aggregated reports. It helps us to create aggregated reports. So group by here helps us to create pivot tables, simple pivot tables, right? And what it's having here? Having here will work as a slicer on pivot tables, So having is okay, will give condition and filter only on the aggregated reports and nowhere else. So having here work as a slicer. As slicer works on pivot tables only, right? In the similar manner on aggregated reports, in the similar manner, having is also a filter, but it works only with the group by. After this here, we have got order by and limit. Order by is very simple. We are sorting our extracted table that we see in the result grid. And limit will simply limit the number of rows in the grid output. It will simply go ahead and limit the rows in the grid output. That's what we see here. Great. So this is the entire select from and where. This is the writing sequence, everyone. Select from where, group by and having. first we are going to go through select from and where in detail. And then, of course, we'll look at the group by, order by, and limit. And we will also see group by and having. Now, first, let's go through select from and where. So far, whatever we are writing here, every time we have to go ahead and get classic models customer, right? So for example, here, I'm going to copy paste the exact same thing here. But now we only want to see the US data. We know that whenever we are extracting this here, we're getting 120 rows, right? Now, how about we need the customer's data only from US? Only from US. If I want to get the data only from USA here, first let's check the spelling. See the spelling here? It is USA in caps right now, correct? Now, how do we go ahead and give a filter, everyone? To give a filter here, after classic models here, after from here, we will go ahead and type where. In the where, we need to give a filter, everyone. So we can simply go ahead and say that in the where clause, go to country column and check that if it is equals to USA. Now, USA is a string, it's a text, so we have to go ahead and write it inside the single quotes or the double quotes. Both will work right now. As you can see here, USA is written here in caps, but I'm writing this here in the lower case here. Okay. Once I will execute this here, look at it. It doesn't matter. 36 rows are there. Yes, wonderful. How do we know that? Okay. So see here, I do understand that. I do get the answer 5 or 7 a lot. The reason is this is the result grid, okay? We are fetching all the list here, but if you look at the output, everyone, whatever is your last output here, that will tell you that we have got 36 rows here. Right now, whenever when we are giving filter here, every time we are writing classic models dot customer, right? So instead of doing this here, we can set this as default. Why default? We will tell SQL here that, see, anyways, I'm going to go ahead and work only on one database. So I don't want to write that database name again and again. I will go ahead and set the database as default. So inside the from here, if I'm going ahead and writing table name directly, you should be able to understand that I'm working with in that default database only. To make it a default database, you can simply write use and name of the database here. The name of database here right now is classic models. I'm going to select, copy and paste here, and here we go. It is here, right? What are the other ways here? Other ways here, whenever you want to go ahead and make anything default here, you can always right click and make here, you can set as default schema here. This is manual process here. You can simply right click and set as default schema here. Or we can go ahead and simply double click on the name of the schema and it will be set as default. Say here, default. And also observe that if I go ahead and execute use classic models right now here, okay, classic models turns highlights in bold. So whenever something is default, okay, it is going to highlight in bold. Then here that it is working fine. Okay. If we are giving it as use classic models here, okay, how we can go ahead and write it again? So right now I'm going to go ahead and write a simple query that select everything from, and this time let's go ahead and get it from the products table right now. If I want to type any table name here, I'm not going to type it at all. I'm simply going to go ahead and double click on that table. I will simply go ahead and double click on the table. And control enter, we have the result grid. Easy. The caution here is which product has a standard price of less than 150. So if you look at the products table here, all right, you will see right now we have MSRP here. Okay. Now we want to find out all the product here which have MSRP less than $150. Let's see how does that work. First thing is when you look at the product table here, how many total lines do we have? 110. Right. Well, how many rows we have here, everyone? 110 rows we have here. Now, what are we looking for? We want to now go ahead and get the list here only for the MSRP less than $150 here. Correct. So we will go ahead and see. We want to see entire columns here. So within the select here, we want to see entire columns. Within the from here, we want to get it from the products table here. But now what we want to do, we want to filter out here, right? MSRP less than 150. So we have to use the where clause, everyone. In the where clause here, okay, we will ask it that go inside the column called as MSRP here. Go where the MSRP is less than 150. And we end the statement here. That's how we write it. That's how we write it. Now the answer will be 98 rows. Answer will be 98 rows. So remember that the sequence, everyone, very, very important here. Select will ask you to select the columns from the location, frame, and where is the filter? Where is the filter? Read this here. Try to understand what is asking here. Which product? It means it needs all the columns. It is not specifying here. Standard price, that is MSRP, is less than 150. Of course, where is the product columns here? In the product table. And then it is asking us to filter it out. Very good. It doesn't understand currency, Rajat. It has only three things: numerical, character. It doesn't understand currency here. Now, let me show you something here. Let me show you all something here. Is a button called as beautify or format. Right now, as you can see here, okay, no matter whether I write in one single line or whether I write it in two different lines here, everything still works. There is no proper way here that we are following up to write. Okay. Neither I'm asking you to put a tab here, tab there, and take care of those things here. No indentation, nothing required. However, they do have a proper way to write it. Okay. To figure that proper way out here, I'm going to copy and paste entire thing here. And I'm going to click on this paintbrush on the right hand side. So this is the command here. Okay. This is the paintbrush here. Beautify or reformat. Once I click on it, it is going to properly write it here. So both are exactly similar. This is also the same. This is also the same here. But the way to write is different. Now, please tell me here which option looks better. Tell me here which option looks better here. First one or the second one? See it from the perspective of not typing in. Okay, but from the perspective that once you come back after the 10 days, which one is easier to comprehend? Once you will come after the 10 days, which one of these is easy to comprehend? First one or the second one? As in when we reach to the more complex ones there, right? For writing, you might find the first one easier to write down here. But once you come back after 10 days and you see a complex statement there, right? To simply view and understand, the second formatted one looks much better. So as in when we will move forward, you will be able to see the difference between the both. Okay, you will able to see this difference between the both, and it is of course personal here, but when you are collaborating with someone, okay, they might not be able to understand this right away, but this is pretty clear for a person if they are someone else and you're collaborating with someone. Okay. Great. Now let's go ahead and see few very common functions that we can use here. Now I'm going to talk about few functions out here, okay, to use in the select here, because we can add calculated columns. We can also have aggregated calculations at the end. What I'm talking about, let's see. So here, we want to go ahead and we want to see here that how many product lines or product category we have in the product table. So if you look at the products table right now here, if you look at the products table right here, we have got product line. What is product line here? Product line here is the product categories that we are selling out. So now we want to go ahead and understand that let's figure out, okay, how many categories are we working with? So here we go. I'm going to go ahead and type here product, selecting from products only. What do we want to see? Select product line from the products table here. If I go ahead and ask it to get me the product line here, is it the correct way? Is it the correct way right now to see how many product lines are we selling out? Does this look correct to you? This is not a good way here. We should have a unique list here. We should have a unique list here. Unique list here. Okay, we don't need any duplicates right now. We don't need any duplicates here. How do we get the duplicates right now? To get the unique list or duplicate here, we use the keyword. We use the keyword distinct. Now, where do I write that keyword? Where do we write that keyword? We write that keyword with select, because select will help us to type down the functions here. So I'm going to select this entire thing here again. I'm writing from in the next line. In the select here, before the product line, I'm going to use the keyword distinct. As you can see in the drop down, I can see distinct right now. So I'm typing distinct here. Type distinct product line like this here. I get the distinct line and I can see right now 7 are there, right? I can also go ahead and write this distinct. I can also go ahead, write this distinct here like this. It will still work. If I go ahead and write distinct like this, okay, it is still going to work. So whether you write it like this here or as a formula here, in both the manner it is going to work. It doesn't make any difference. It depends on your preference. How do you want to type it? Now we know that there are 7 counts here only when we look at the output, right? Only when we look at the output, then only we know that. Yes, very good. Thank you. So how about that? I don't want to say, look at the output here. Instead, I want to count that how many are there. Count how many product line are there. So how do I count this here? To count here, I am going to get the exact same thing. And now here after select, I'm going to simply type here count. You have a keyword also, you have a library function also. There is absolutely no difference. So I'm going to go ahead and get the count here. I'm going to get the count here. I'm going to open the parenthesis up for count distinct and I close it here after the product line. It will give me the count here, right? But while I'm writing this like this here, look at the name of the column. Name of the column is not good. It is writing the entire formula right here. So we will go ahead and rename the calculated column. Now this is a calculated column, everyone. Why? Because right now, this calculated column here, okay, it is not the part of your database. We are extracting something out here. We'll go ahead and rename the calculated column here and what we call this here as alias or the alternate name. Here. How do we write the alternate name here? How do we write the alias here? So there are multiple ways out here. I'm going to show you 3 ways here right now. First thing here is alias here is nothing but the alternate name, everyone. Okay, and it will only appear in the result grid. First way here is I can go after the count here. I will go ahead and type AS. And after AS here, I can write the name inside the single quotes. So for example, here I want to type the here total product line, right? One way is that, and when I execute this, you can see total product line here. As you can see right now, while I'm writing this name here, I am not giving any space here. I'm not giving any space here, but if I choose, I can give a space here, and the space will appear here. In practice, we don't give the space, but writing AS like this, we can. Another way to type here is, I can definitely forego of the single quotes. Even if I don't give the single quotes here, we can still type the name of the column here. However, now we cannot afford to have a space here. Okay, our name has to be in the one single string. Now we cannot have the space because we are not writing inside the single quotes here. Still we get the output. Still we can get the output here. Another way to write the alias here, we can simply go ahead and forego AS altogether and directly write the name in continuous string and we still get the output. You can choose anything here, but as a beginner here, prefer this one. As a beginner here, prefer this one. Because we will know that when we are giving the alternate name. Okay. And as in when we move forward, of course, we'll go ahead and keep, you can go ahead and choose anything that you want. Okay. See the alias here. Give the aliases, see the different ways to type it. Right. Very good. Now let's go ahead and see functions, everyone. Let's go ahead and see the functions here. These functions here can be mathematical, they can be logical also, right? And through which what we can do, we can go ahead and add a simple calculated column. We can add a calculated column in the output. And then to give the filters here, we are going to see multiple operators with where clause. We are going to see multiple operators with where clause. Now in these operators here, we have already seen the comparison operators. What are the comparison operators here? Comparison operators are simple equals to, less than, greater than, or any combination of them here, right? Any combination of them here. Figure it out which one works for you for not equals to. Okay. We'll see what works here. So this is comparison operators here. Let's see a simple function right now. So in the products table here, when we are working with the products table, everyone, okay, what we have seen in the products table? In the products table here, we know that there is the MSRP, right? There is the MSRP here. MSRP is the price or MRP that we are placing for the customers there. So let's say the company decided that we want to go ahead and we want to create a new MSRP. How are they going to create the new MSRP? They want to go ahead and increase the MSRP here by 10%. They want to increase the MSRP here by 10%. And they want to create the new MSRP there. So to create the new MSRP there, okay, we will go ahead and get the 10% of the MSRP. Can I go ahead and write this new MSRP calculation like this? 10% as 0.1. 0.1 multiplied by the original MSRP. Now, since MSRP is common there, we will take that out and we can multiply the entire 0.1 there. And ultimately, we can write new MSRP like this here. Okay. So this is what we are going to type, MSRP multiplied by 1.1, and we get the new MSRP here. Now, how do I write this here? First thing first, all right. Select from product here. Inside this here, from product is going to remain same. So I will go ahead and type the from product first so that we are through with that. Now, instead of selecting everything here, I will go ahead and I will go back to the products table here. And maybe from here, I need product code and the product name. And then we need MSRP. But this MSRP here, okay, I'm going to rename this as old MSRP. This is our old MSRP, everyone. Correct? This is old MSRP, comma. After comma here, I'm going to the next line because here now we want to add a calculated column called as new MSRP. To add that calculated column here, I'm going to get MSRP. We are going to multiply that MSRP with 1.1. And I'm going to name this as new MSRP. This is our new MSRP. This is our new MSRP here. If I go ahead and calculate like this here, we get the output here. Let's see. But this output here contains 3 decimal points. This output here contains 3 decimal points right now. So we can go ahead and we can control these 3 decimal points here. How do we control that? By using another function here called as round. So I'm going to use the round function here. You can see that in the drop down. So I'm writing round function, opening the parenthesis here and closing the parenthesis after 1.1, type a comma. I want 2 decimal points. So I'm typing 2 here and closing the bracket. Same as Excel, everyone. And here we go. Right. And I'm going to simply reformat it just to show you how does it look like. So if I reformat this here, if I go ahead and reformat this here, everyone, this is how it is going to look like. Much easier to comprehend and what is happening here. In the similar manner, we can simply go ahead and use other aggregate functions here. For example, we can use minimum, maximum, count, average, round, and distinct. For example, if I ask you right now to get the average price for all the product, can you get that? Average price, meaning average MSRP of all the product, all product at once. So this is an aggregated calculation. How do we get this here? We again start with select here. And we are selecting from the products table. First, we will define that. Now we go here and we want to calculate average. So we go ahead and get the average function here. Inside the average function here, we simply go ahead and type MSRP. This is our MSRP here. As usual, okay, we have to give the alias here. So we can give the alias here for average price. As you can see right now, I am not writing any other categorical column in front of it. I'm simply writing the aggregated calculation here. I'm not writing anything in front of that, in no category at all. When we do this here, we get the only average price here. Now you know that, okay, now we can go ahead and round it off because it is too huge a number here. After MSRP here, we can ask it, maybe I want looking for 2 decimal or 3 decimal points here, and we can get it like this here. So this is average price, everyone. Yes, sum of and average of. So this is why, this is how we can get the average. When we don't write any category there, okay, we get the one single number calculation out there. We'll move forward and we will see about here logical operators. We are going to go ahead and talk about logical operators. What logical operators are? I'm talking about here and, or, between, right? After logical operators here, we'll go ahead and we will talk about group. We will move forward, okay? We will see more operators. For example, we are going to talk about more operators that we can use with where. It means filter operators. Okay, we will see about more operators right now. And we will learn about the wildcard. We'll move on to group by, having, order by, and limit. We will move on to that too. So we are going to understand the entire select sequence today. Of course, other than logical operators, we'll move on and we'll see more. Yes. First, we are going to look at comparison. We have already seen the comparison operators. Okay, equals to, less than, greater than. That's there, right? And then we have got logical operator. We will see that today, what logical operators are there. And we will also see more functions, meaning we are going to see date function, text function, and more different types of functions out there. And we will also discuss group by and having. But while writing these functions or understanding group by and having here, we will have to go ahead and discuss about a very important part, that is the writing sequence and the order of execution of a select query. First thing what we do here is we go ahead and use classic models as a default. We have to set that as default so that every time we are using any table name here, it will always go ahead and find that table in classic models database only. Okay. Now let's talk about logical operators. Now I'm going to talk about logical operators here. What are logical operators here? Logical operators, before logical operators, we were looking about comparison operators. What are comparison operators, everyone? Comparison operators are equals to, less than, greater than, or any combination of them. Okay, it can be here not equals to, and this can also be not equals to. Now, once you have these comparison operators, when we were using these comparison operator like here, or maybe yesterday here like this, we were checking only one condition, right? This is I'm checking only one condition. We are checking only one condition here. Meaning based on one condition only, we are going ahead and filtering out the entire table. However, now if I want to go ahead and want to filter out by two or more conditions while I two or more conditions here, then I need to go ahead, filter out by two or more conditions here, then I need logical operators. What are the logical operators here? The logical operators are, so first let's talk about and here. So what is the and logic here? And logic says that it is going to return true only if both conditions are true. What does that mean here? And mean that I will go ahead and set two conditions or more, right? We can go ahead and set two conditions or more. Meaning I'm going to go ahead and check multiple conditions and each condition has to be true. Each condition has to match. Each condition has to match for the output. Meaning that has to be all true. That has to be all true. If any one condition fails there, then and doesn't work. So for example, I want to go ahead and find out all the vintage cars who has price less than $200. Meaning I need both the conditions satisfied. That vehicle has to be vintage car and the price has to be less than $200. So whenever we are applying a condition where we want multiple conditions to be applied and each and every condition has to satisfy 2, in that case, we apply AND. Then what is OR here? OR is just opposite to AND here. In OR also, I will go ahead and apply the multiple conditions. However, any one condition will do. However, any one condition can be true. Any one condition can be true. In which cases we go ahead and use OR function here. What is an OR condition? So for example, okay, most of us go to office or any organization we attend to, any university or something. So when you are going ahead and logging your attendance, okay, either it can be with biometric or you should have a card. If you don't even have that, you forgot, okay, even if that is not there, you will go ahead and sign in a register. So if you go to your organization there, let's say you forgot your card. So they will say, it's okay, use your biometric. And if you don't have biometric, they'll say, it's okay, sign in the register and go. Meaning you have multiple options by that. You can choose any option and you will be let in. In a similar case, what happens in OR here? In OR here, I will say that, okay, I need a person, okay, who lives either in USA or in France. Or I need a manager that can work in marketing department or in sales department. So right now, OR will, if any one condition is satisfied, I'm good with that. I want that row in the output. That's all. What is between here? Between is pretty simple. Okay, between is always used with and it will simply give us the range of values, and it is always in numerical values, of course. So it will simply go ahead and give us the range of values, and usually the range of numerical values. For example, okay, I want the credit limit I want all the customers whose credit limit is more than $75,000 or between $75,000 and $100,000. So like that, I might need a range of numerical values to be filtered out. It means we have got more than one condition. So why logical operators? Because we need to go ahead and check more than one condition here. So let's see how does this help. So here we will go ahead and check two conditions here. So for example, I want to go ahead and check that go ahead and find all the product whose MSRP is greater than 100 but less than 180. Whose MSRP is greater than 100 but less than 180. Now they belong to AND because there are two conditions here where MSRP has to be greater than 100 also and MSRP has to be less than 182. So first thing here is we go ahead and we select product. I will go ahead and type use classic models again, just in case just in case, okay, we forget that. So what we want to do here, we want to select everything. From where? From the product. This is also done. Now, we have to use AND here. How do we use AND? So we will use the where clause here. In where clause, I'm going to say that go ahead and go ahead and find out where MSRP. So first we'll get the MSRP columns here. Here it is. Where MSRP is greater than 100, and again, MSRP is less than 180 here, If I go ahead and search for that here, okay, let's see. Look at the MSRP column, and we do have everything greater than 100 but less than 180. Greater than 100 but less than 180. How many rows I have here? 47 rows, right? So here, this is good. This is what we have used here. We have used AND here. This AND here. Now you must be thinking that why have you not written greater than equals to or less than equals to here? All right, because we have a choice. We have a choice here. Okay, I have a choice here. If I want greater than less than here, if I want to type equals to, I can. If I want to include both of them here, I can. All right. So with the AND here, I have the choice, right? Go ahead and get how does AND works. And then we are going to talk about between. Yes, I understand that. It does more look like between. We can solve it with that too. And yes, we can. But first go ahead and see and come back. Then we'll talk about the between. We'll also talk about the difference between writing with and between. Now here, let's talk about between. So this is and here. Now after and here, it looks more like between portion because it is in numerical range right here. So here I'm going to use between. So how does between works here? So we will use between and together. I've told you before. So how are we going to write between and and together here? To write between and together, I'm going to go ahead and get this part exactly as it is. And here where MSRP is between, what do we write here? That where MSRP is between 100, 100 and 180. 100 and 180. Very simple. Now, when I go ahead and look for this here, remember that between here by default includes both 100 and 180. So we don't have to go ahead. We don't have to go ahead and include it. We don't have to worry about the equals to sign here, as we have to understand in and right now. So in between here, by default, it is going to include both the intervals right now. That is 100 and 180. So it is specifically looking for greater than equal between 100 and 180, including both the numbers right there. The output is going to be exactly similar. This is between everyone. Now I have a question here. Now here, if I ask you right now that can you get me the list of the customer, those who are either living in USA or in France? USA and France. So I want a list where people are either living in USA or in France. Meaning I want a list where people are living in USA and France both. Oh, so why do I say that we are going to use or here and not and? Because basically what I want, I want a list where customers are living in USA and France, either in USA or in France. So we have to go to the customers here. If I'm checking here every time that which customer lives where, so how we will check manually also, we will go ahead and check, is this customer lives in USA or France? France, if they live in France here, we will be like, right, okay, filter that. Now we will go ahead and see USA. This matches the condition, we will filter it. We'll check again, is this person lives in France or USA? No. Then we will go ahead and cross it off. So in this way here, we will go ahead. This is why we use or, because no person is giving us the two addresses in one single row. So here we go ahead. This is list of customers living in USA or France, right? So we will go ahead and use or. How do we use or here? So select everything from is going to be same here. I'm copy pasting right now. From where? From customers. From customers. Then we have got where. Where? In which particular column we are about to give the filter? Country column here. So where country is equals to USA here. Or country is equals to France. Remember that I have to use the country twice here because this is how we go ahead and see in and also. Okay, so if you're having two separate here conditions, you have to go ahead and rewrite the country column here. Okay, if I go ahead and use this where right now, and let's check the country here. Yes, we do have only US and France. That's how we go ahead and filter out. That's how we can use or here. So for now, okay, let me show you right now here. If I will go ahead and execute this here, I'm getting how many rows written? 48. And what do I have in the output? US and France, right? That why we are writing country equals to again. Even if I don't write country equals to here, okay, then also I'm getting an output. You are definitely getting an output. How many rows are you getting here? 36. Check your country column. Do you have France here? No. Why? Because it has no idea where to find France. It has stopped here and given you the answer, right? That is why we have to go ahead and include country equals to here, because or only understands that after this something else will comes. That's it. All right. Now, if I will ask you here, that okay, now go ahead and give me the list of customers living in either USA, Australia, or France. It means that I'm going to ask you here to add one more country. How you will go ahead and how will you go ahead and add one more country? You have to write or again. You have to write or again, and then you have to write Australia again. Great. So here we go ahead. If I ask you here that go ahead and get the country equals to Australia here, it means that you have to go back again. You have to write the or again. You have to go ahead and write the or again. Type country equals to once more. Type country equals to once more. and get the Australia again from here. You have to go ahead and get the Australia from here. Right? So here I have to go ahead and get the Australia again. It means that if I need the list of 10 countries, maybe I list the list of 10 product out there or product IDs, every time I have to go ahead and type equals to column name, equals to column name, or equals to column name, or. I don't want to write it like this multiple times. So what we do here is we go ahead and use the operator there. We do have 53 rows. Now here I'm saying what is the objective right now here is this. Objective here is that I don't want to write country equals to here because as you can see right now, we are making mistakes, manual mistakes here. We are forgetting to write country equals to, maybe we forget to give the proper quotes around here or whatever. So instead of using, whenever we have to go ahead and find multiple values inside one single column here, in that case, we can use another operator called as in. We are going to use another operator here called as in. This in operator here is going to help us write a list. In operator helps us to filter out a list. And this in operator is going to, whatever list I will, how does it work? I will go ahead and type in. Inside this, I will give a list. For example, value 1, value 2, value 3 here. And this in is going to act like exactly like or. So V1 or V2 or V3. It is going to act like that, right? So this is how we will go ahead and use the in operator. Inside the in here, you go ahead and filter out a list. So it helps us to define an entire list right in. Follow along. So first, till here, everything is fine. Select everything from the customers here. But instead of everything here, I'm going to go ahead this time and I'm going to select only customer number, customer name, and country. Okay, so that we are able to see clearly the output. Now I'm going to type here where country in, where country in. After in here, we will give a list here. What is the list here? List here is going to be first is USA. So I'm copying and pasting USA right here, comma. I'm copying and pasting France here. Then I'm copying and pasting here, Australia. After that, also, if I need to go ahead and add anything in the list here, now it's quite easy. I don't have to write country equals to on multiple times or remember to type or here. When I go ahead and execute this, I still get 53 rows returned. And I have here 3 countries here. So this is the in operator here. In operator is used in place of or. In operator used in place of or whenever we have a list to filter out. Let's go ahead and now we know how to use the in and or between and in operator. Remember that. How are we going to proceed here? I'm going to show you one example for each operator. And at the end, we'll solve a small problem that is going to include everything that we have learned in one single problem. That's how we are going to proceed. Okay. So right now, please go ahead and let's see the next one here. So till now, whatever we have been filtering out, everyone, till now, whatever we have been filtering out, it has been always either one condition or multiple conditions. And every time we were looking for the entire string. What if I will go ahead and ask you that can you get all the product line? Can you get all the product line where any product line or any product category where in which car is written, any product in which name car is written, meaning this time we are not going ahead and asking you to find a proper vintage car or some car here. No, and we are simply asking you here that go ahead and filter out wherever the car is written. We don't care. Okay, so in this product line inside the products table, how do we get that? This is where we use wildcard. And we can define the wildcard with the help of like operator here. Like operator here. Now, what are the wildcards available to us? The wildcards available to us here are percentage and the underscore sign. Percentage sign is widely used. We will see here why. Percentage defines 0 or more characters. Percentage defines 0 or more characters. What is meant by that here? So basically, I can go ahead and ask here, what does percentage defines as 0 or more characters? What does that mean? If I ask it that go ahead and find percentage car. So basically I'm saying here that before car, there can be any number of characters. There can be any number of characters. Any number of characters can be there. If I will go ahead and type car percentage here, it means that, and it ends at car, and it ends at car. If I will go ahead and type car percentage here, it means we are communicating here that it is going to start with car, and at the end, there can be any number of variables there. If I go ahead and type percentage car percentage, basically we are saying here the car somewhere in between. Car somewhere written in between the string, and there can be any number of variables before car and after car. And all of this is checked, within a string, So here inside a string here, it is reaching word letter by letter there, right? So this is the percentage here. Now, what is the underscore sign now? This underscore sign here. This underscore sign here, it is fixed. What is meant by fixed here? If I will go ahead and write like this, okay, 1, 2, and 3. If I go ahead and write like this here, so I'm defining right now that in total, it is a 3-letter word. In total, it is a 3-letter word that ends at A, letter A. Go and find that out. Maybe I will go ahead and write like this. It means that this is a 4-letter word in which O comes at the 3rd place here. Go ahead and find this pattern out. Yes. So this is how, if you are looking for a fixed pattern, you'll use the underscore sign here. If you're looking for a variable pattern, you will go with the percentage here. Most of the time, percentage works. And that is used a lot. Now, let's see an example, everyone. So here, what is underscore here? It is a fixed characters here. Okay, basically looking out for any pattern, looking out for a pattern. What is the example here? Example is exactly this. Okay, we want any product with car in it. So we are looking for get all product lines with car written there. Now, since we are not that familiar with the data set, okay, I have to go ahead and check each and every line there and each and every number there. Instead of doing that, I will go ahead and say that, okay, let's go ahead and get everything from the cars. Let's go ahead and get everything from the products there. So here is the products table, everyone. Great. So select everything from the product where. Now this is where, and now we will go ahead and type like. Where, like what? Where product line is like. Where product line is like car. Now where the car should be there. So I have no idea where the car is going to be, or whether it is car or cars. I don't know that. So I'm going to simply go ahead with percentage car percentage, that there should be car somewhere in there. It is at middle, it is after that, I don't care. And it is, we'll go ahead and get the cars. Okay. Go ahead and get that, please. Now, in the similar manner here, please go ahead and get all product name. Go ahead and get all the product name with the word Ford in it. I don't know where it is. So here, everything is going to go, everything is going to be exactly similar to this here. And after this, we will need product name. And after product name, we'll go ahead and write like, and it will be Ford. And we will have 15 rows there. Very good. Let's look at the wildcard here. So how do I use a wildcard? If I want to go ahead, how do we know that this time we use like? Because I'm asking you get all the product name with the word Ford in it. I'm asking you to find not an entire string, but I'm asking you to find one word inside each name. So this is how you will know that where to use like. Because I'm not asking you to go ahead and find a vintage cars. No, I'm asking you to find anywhere if car is written. Okay, so now to understand about the wildcard here, find the customers whose first name starts with letter M and have exactly three characters How will you define this here? We have to go for with the customers there. How do you think we will write it here? So if I will select everything from customers, where customer first name here is like what? I want M as the first letter. It should have exactly three characters, so maybe 1 and 2. Do we have anyone with name like this? Yes, great. This says that anywhere in the name M is there. No, I'm saying starting word letter should be M. So if it's starting word, yes. Oh, there is one person here. There is one person here. Only one. So this is the wildcard here, everyone, right? This is the wildcard here. Now it can be used in multiple ways. If you are going to look for a pattern there, right? That's where we can use the underscore signs here. And these are 2 underscore signs, everyone. Why? Because you're looking for exactly 3 characters here. All right. So this is all about the filters and the operators right here. Okay. It's very, very good. Very good. Right. So we know how we have to go ahead and find select. Okay. And in the select here, what we need to count here. And from which table are we working with? We are working with customers table here. So I can say count customer number. From where? From customers table. Now we have to type where. Now we know that how to get the list here. So in the where we have to go ahead and get the list. That is country in this particular list. Very good. It means we understand right now that where and these operators can be used with each other too. Very good. The count of the customer number here will be 53. Now we'll go ahead and discuss about the functions, everyone. Yes, more functions. Now, what is the next here? Right now, we have seen multiple operators, how to give the, how to go ahead and give multiple conditions here for filtering out. Now, let's talk about the functions here. What type of functions can we see here right now? So here we are going to go ahead and talk about first string or text functions, then date functions. We'll also go ahead and learn about conditional statements, and we will also discuss about the null values, how to find out the null values, how to deal with the null values too. And we can do that by using the functions only. So we will go ahead and discuss about these functions right now. First thing that I'm going to discuss here is the text functions. That's why I need your attention here right now. What we are going to discuss about the text functions here. So let's see how many different types of functions can be here. So these functions are going to be exactly similar to what you have seen in Excel or on any other platform. They're mostly similar on Tableau, SQL, Excel, and other similar platforms. For example, here's a function called as upper. What does upper do here? Upper will make sure that your smaller case letter gets converted into an uppercase letter. Similarly here, okay, we have lower function here. Lower function makes sure that your uppercase letter changed into a lowercase letter. Then you have got here another function called as length. What does length do here? Length will tell you about the length of a string, or how long your address is, or what is the length of your data point inside your rows, inside one single cell there. Then we have got trim function there. You also have left trim and right trim. What does trim function will do here? Trim function will get rid of the extra spaces. Where extra spaces? Well, it can be a sentence, it can be a name. It simply gets rid of extra spaces. It understands that there should be one space between each word that it understands. So there should be only one space between each word. If there are extra spaces, trim is going to trim them down and keep whatever is required. Similarly, here you have more examples here. For example, you have got here substring, you have got the reverse out there, and a lot more. There is one very popular function in here, concatenate. Have you heard about that? Concatenate, everyone. Okay, it joins the two or more strings together. So here it is join or two or more strings here. Yes, it is because it is the most commonly used text function here, and one of the first text functions people usually learn in their on their work, right? So concat here simply joins two or more strings here. Yes. All right. No worries. Those who didn't know about that, we are going to learn something new then, right? You will see that why it is used most of the times here. So let's go ahead and look at that. So for example here, okay, we want to go ahead and look at the customers table, everyone. In customers table here, we have a customer name. If you remember the customers table, okay, do you remember that here our customers are the vendors, right? Look at the vendor's name here. Land of Toys, Mini Wheels, Euro Shopping Channel, Volvo Model. And this is the name of the companies or the vendors out there, distributors basically. So our Spock details are here. Our Spock details are here. But the Spock details are written in two separate columns, first name and last name. So what we want to see here right now, we want to go ahead and look into, both the names in one single column, both the names in one single column. So let's go ahead and get the full name of the contact name here of customer in one single column here. How do we get that? So first thing is we select everything from the customer. So I'm going to go ahead and not select everything from the customers here. I'm only going to select customer number here and customer name. Now after customer name here, I would like to see entire full name of a customer. So here we will use the function right now. So I will first let go of from right here, from customers right here. Now here I will go ahead and type the function. What is the function here? Function is concat. So I can write concat here. And you can see that it's a function right here. I will select concat. Now inside concat here, what is the syntax of concat? Just the strings, string 1, 2, 3, 4, 5. So in the concat here, first I will go ahead and select the first name, right? Now after first name, how do I write a full name? I will go ahead and type a last name here. So here I need simply two strings tied together. So I'm going to select this and execute this right here. Look at the output, everyone. On the screen, please. Look at the output, please, and please tell me, does this output look correct to you? Does this output look correct to you? I've got a space here at Karine. I've got a space for Janine and Jonas. I've got a space at Diego and Christina. I got a space here in the name here, Mary. So in few names, I have this space, but in few names, I don't have this space. Any idea why few names have this space and few names doesn't? Because here it already had the space here. So when someone was writing the first name and last name right here, when they were entering the data here, they might have added the extra spaces, maybe after the last name or maybe before, after the contact first name or before the contact last name. So they might have some extra spaces somewhere, maybe at the start or the end. So what I have to do here, first I have to go ahead and trim these spaces here. I have to go ahead and ask you to trim these spaces. Now the trim spaces here, trim will work on individual column only. So I have to write the trim function here for individual column. It will not work outside the concat like Excel. So I have to go ahead and write the trim function for individual name here. So when I'm writing trim function for first name and last name both here, and now when I execute this here, now I'm getting absolutely no, now I'm getting here absolutely no space. When I'm getting absolutely no space here, then we will go ahead and add few spaces right here. So here, single quote space, single quotes, comma again. And now here we have a proper output, right? Of course, the name has to be given here. So I'm going to give the name here as contact name. Right here. Of course, it is not going to make any changes in the existing database. Existing database will have the separate names. It only affects what we are trying to export or retrieve from here. Okay. So this is the full name here. I'm going to beautify this for you so that you can see how it is going to look proper here, because it now the functions here are going to look a little bit longer. So here I'm going to beautify this right now or reformat that. I will show you how the reformatted version looks like. This is how easy to look at. We are moving forward right now. So we can see here contact name here right now, and we have seen how to use trim and concat together. Now, once we have seen the trim and concat together, go ahead and get full contact name with the full address within the same query, right? So the query that we have written here, within this query itself, please go ahead and get the customer name and the full contact address too. Go ahead and get that, please. So basically, what you have to do is you have to copy and paste, right? Copy and paste. After you've copy pasted here, after copy paste here, type a comma, press enter, and type concat again. But inside this concat here, I would like you to go ahead and get the address, get the full address. Get the full address. What does full address is going to consist of? Full address is going to consist of address line 1, 2, 3 till the country, right? Please go ahead and type contact. I know concat here. I know you can do that. We do get the answers here, but there are a lot of null values right now. What does null values tells us? That Karim, Smith, Jay, and King, they don't have given us the address. Only the Australian collectors, they have given us the address here. So let's go ahead and check. Do these people don't have the address? If I go to the customers table here, and if I try to check that here, I see that no, everywhere I have the addresses. However, if I talk about this right now, yes, I do have null values in between. So for example, address line 2 is not there. In some cases, state name is not there. So I have null values in a few of the cases here. Few cases, I don't have any null values. This is quite standard, right? So whenever you guys go ahead and to any website portal, maybe you're shopping something, right? So on the website, if you're shopping, you have to enter your address. In that, they might give you address line 1, 2, 3, city name, state name, neighboring area, right? So not every line is mandatory. Only address line 1 is mandatory and your city is mandatory. Other than that, they will, and pin code is mandatory or postal code. Other than that, nothing is mandatory because not everybody's address is going to have address line 1, 2, 3, 4, 5. Not everyone is going to have that. In that case, the address line 2, you can see it has multiple null values right here. And because of this null values, our concat is breaking. Concat is not able to deal with null values. So even if only one column has a null value in this list, even if one column has a null value here, concat breaks and gives null as the output. Concat breaks and gives null as the output. So here what we understand about concat? We understand about concat here that concat cannot work with the null values. It cannot deal with that. In the ideal scenario, the function should go ahead and look at the null value, skip that and move forward and go to another column and fetch whatever value is there, right? So what we do here, we will go ahead and find out how many null values are there. And how do we find the null values? We simply ask SQL, is there null? Is there a null value? So for example, here I will ask it that go ahead and select, and count all the values, from all the columns there from the customers table, where address line 1 is null, or address line 2 is null, or city is null, or state is null, or postal code is null, and likewise. It means you can keep on checking like this here. If I go ahead and check it like this, it's tell me here that, oh, there are 121 counts here. It means that there are too many null values already there. Now, how do we deal with this null values here? To deal with this null values here, we have a function here called as coalesce. What coalesce do here? We'll go ahead and use the function called as coalesce. What coalesce will do here? Coalesce will simply ignore the null values. So what a coalesce can do? Coalesce is very good at ignoring the null values or replacing the null value with any kind of symbol, function, or whatever we need. So it can replace the null value with any text, number, or symbol. Okay. So it can symbol, basically we are talking about separators, right? So it can do anything here with the null value. It means coalesce can deal with the null values. It understands that it has to read the null value. It has to identify if there is a null value and then move forward with it. How does the syntax of coalesce looks like? So this is how the syntax looks like, everyone. So in this syntax here, inside the coalesce asks here for a column name or a string. It will ask for a column name or a string, and it will identify if this null or not. If this is not null, it is going to go ahead and give this exact value as the output. If this particular row inside this column, if any row is null, if the value is null, now here you get to replace the value with any value there. You can also leave it blank, right? Or you can go ahead and give any kind of number, separator, NA. You can write anything out here. You can go ahead and write anything out here. So you can go ahead and replace the null value here with any symbol, text, or anything else, or maybe leave it blank. So that's how coalesce help us to concat it better. So we will use the concat and coalesce together. So I'm going to show you how the concat and coalesce can be written together. One more thing, coalesce has to be used for individual column here. It cannot be used for all the columns at once. So what I'm going to do here is I'm going to copy the entire same thing that I've seen before. And here we will use concat and coalesce together. So here I will type after full address 1, I'm going to type a comma again. And now I will go ahead and type concat again. So this is concat here again. Inside the concat, what is the first thing we need? Address line 1. But before I need address line 1 here, I will go ahead and type coalesce. And inside the coalesce here, I will get the address line 1. Now I'm going to ask coalesce that go and check address line 1 column. And it is a row-wise calculation. It will go and check that row. If you find that row is null, here, okay, go ahead and replace it with nothing. Meaning just keep it blank. How do I define blank here? Single quote, single quote. No space, nothing. Single quote continuously. Replace it with nothing. I can also go ahead and replace it with a comma. That is also fine. Now I'm going to replace it with a comma here maybe. If there is a null, or just leave it blank. Just leave it blank. So you can write anything also. You can write NA also. For now, I'm not doing that. So I have opened the coalesce here and I'm closing the coalesce also here. Now I'm typing a comma here. After comma, I'm going to give a simple separator like here that if this is address line 1, after that I'm going to get address line 2. Between these two here, I want a separator and that is comma. Now I'm going to type comma here again. For the third character, I'm going to type coalesce again. Inside this, I'm getting address line 2. And we are aware that address line 2 has nulls. So I'm going to go ahead and type here NA so that we can identify that okay, there was a null value. Because we are doing it for the first time here, so we should be able to identify that. Now, in a similar manner, I will go ahead and write it for the city and state too. In the similar manner here, I will go ahead and write for the city and state too. So I'm typing comma again, and we are getting coalesce here. This is here for city. If city is null, I would like it to simply leave it with a hyphen so that I can identify what's going on. And now here, I will go ahead and type coalesce again. This time I'm writing it for state. If the state is not there, just leave it blank because it is at the end here. And remember here, always close the bracket for coalesce here. And at the end, close the bracket for concat. I'm going to name this as full address 2. And look at the output. Wherever the address line 2 is not there, I'm getting the NA here. Right? I'm getting the NA here. And after the address line 1, okay, this NA is properly written here. After this NA here, if I want it to be written properly, I can give a space and comma and see it looks better. Go ahead and get this, please. Let's see there how coalesce is working. Try to understand that. I will also go ahead and show you a beautified format, reformatted here. Reason is it looks much better from your end once you will, if we are trying to understand and read after 2 days also, okay, it is going to look better if you reformat it. Look at this here. It looks much better. Now you can clearly see that here you have the first concat. This is your second concat. This is your third concat with coalesce. Where are you typing separator, where you're not giving any separator, everything is quite clear. Now we can see coalesce is helping us in getting the entire, whatever is available in the address, everything is here. Now next year is, see, this becomes very complex, right? This does has the flexibility, by the way. What is the flexibility here? Flexibility here is I can give multiple different types of separator. Maybe I don't want to give 2 commas here. Maybe I want to give 1 comma and 1 forward slash here. So here we have got the flexibility to give multiple separators. We do have the flexibility to replace the null values with any value we are looking for, with any kind of value we are looking for. So we do have this flexibility here. However, there is one more function here which can help us in cat WS, concat WS. So concat and coalesce here this is the advantage of concat and coalesce right here. I'm going to write this here, very important to know the difference. So concat and coalesce advantage is this, right? Multiple types of symbols and delimiters, but we do have one more function here called as concat WS. WS is with separator. WS is here means with separator. So this is the concat with the separator. This is the concat with the separator here. So what does concat with the separator does? First thing that it does is it can ignore the null value completely. It doesn't replace it, it simply ignores it. It can read the null value and it can skip the null value. After skipping the null value here, it is going to trim. We have to apply trim if we want to, and it can add only one type of symbol or delimiter, meaning only one type of separator. We can add only one type of separator. We do not have the flexibility of adding multiple separators. Neither we can replace null with any value, right? So concat WS does the work, it gives us the output, but with the limitations of only one type of separator here. Plus, it doesn't replace the null value with anything. It simply ignores them completely. So how do we go ahead and write this concat WS? So inside how does the concat WS looks like? So let me show you that. If I want to use trim, I have to use the trim as we have seen before. Okay, I have to use the trim as we have seen before. So this is how the concat WS looks like. First, we'll go ahead and define the separator, right? Then we are going to type address line 1, 2, 3, whatever we want here. And that's it. Quite smaller than what we have typed here, right? So let me show you how we are going to type this out. I'm going to copy paste from the top here. I'm going to get all the 3 columns right here. After the full address true, type a comma and press enter. Why? Because now we are adding a new calculated column after full address true. So now here I'm going to go ahead and use concat WS. This is concat WS with separator here. Inside with separator, first thing that I'm going to define is the comma as a separator there. After this here, I simply need address line 1, 2, and 3. And if I want to use the trim function there, I can. So I'm going to use this right here. Right here. And I'm naming this as full address 3. Naming this as full address 3. Let's look at the output right now. So let's look at the output, everyone. So this was with the full address 1. We have got null values. Second one is called coalesce and concat. This one is concat WS. And concat WS does look quite good. It does have few extra spaces here and there, but we can apply trim to these columns and we can get it right. This is concat WS, everyone, concat with the separator. Now let's continue here with substring, everyone. Substring here. Let's understand about the substring there. Okay, so here we go. This is substring. Substring is a very simple function. Okay, we'll find it again at most of the places there with different names. So substring, what does it do? It simply creates a subset out of the string, right? It simply takes out of some part or some words out of the string there. First, what is the syntax here? Syntax here is that it should be column, right? It should be start position and how much length. So for example here, those who are looking at this for the first time here, so let's say this is the name here. This is a string, everyone. Out of this string here, if I will go ahead and ask here that go ahead and use this string, go ahead and use this string there, use this string here, and start extracting from position number 3. And get the length, position number 3, and get the length here, let's say 5. So what will be the output? So here, we will start at the third position. This is first, this is second, this is third, right? So we start at R. Then we will get D. A space will also be counted. A space will also be counted here. So 1, 2, 3, 4, and 5. So output will look like this. RD space AN. So we do we understand how does substring works? A space will also be counted. Okay. So let's go ahead and see an example right here. So let's extract a few letters from a string or a text. So we have a product code, everyone. Product code here is, if I will show you the product code, it is quite long. We have S10, 16, 78, and a lot more here, right? So let's go ahead and extract the first few letters here. So maybe we can go ahead and say that select product code, okay, from the product. So select, I'm going to talk about the products table here. What are we trying to select from the products table here? First, I'm going to go ahead and get the product code so that we know what we are doing here. Now here, I'm going to apply the substring. This is substring here. Inside this substring, I will ask it that read the product code. Okay. Start here with the first position and get me maybe 4 letters afterwards, right? If I go ahead and get this here, this is what we get. Well, the exercise question here is that generate a custom product code that combine the first 3 letters of the product line, and a formatted price, formatted by price column. So there is a by price column here. That by price column has to be formatted. What do they mean by it should be formatted here? If you look at the by price column here, you will see that there are 2 decimal points. We don't need any decimal points, right? Formatted by price means we need 0 decimal points, 0 decimal points here, and a unique reverse identifier. Reverse identifier here means I want to go ahead and use the product code here, but I will go ahead and reverse it because I want it to appear uniquely. So it's a unique reverse product code. So I will simply reverse the unique product code here. And I don't want, now once this will be done, okay, I don't want to see the entire data. Do we understand the question here? So we are using the product table. After using the product table, we are creating a separate product code, a custom product code down here. So step number 1, first thing is, where are we working? We are working with the product. So I'm getting here, select everything from the product. Now in the product here, I will get the product code, of course, right? And I will also go ahead and get the product line because this is the name. These are the 2 things that we're using right now. Now, after this here, now we start. First, we need to create a code here, right? Now, first 3 letters of the product line, and then a buy price with the formatted buy price without the 0, with the 0 decimals there, and then a unique reverse with the product code. And all these 3 should be just concatenated as one here. So I'm going to go ahead and write concat first. Now inside the concat here, now we will go ahead and get them one by one. So what is the first thing here? What is the first thing here that we are typing? First three letters. How do we get the first three letters out of the product line? Any idea? What we should use here? Right. So you all know how to use a substring now. So let's use another function. You can also use left. You can also use left in this case because it is quite clear that I just want the first three values, right? So how do we use the left function here? Left function here, I can write product 9 and I can simply say, get me three things from the left. Easy. Far shorter than the substring, right? So if it is extreme from if it is from the extreme left, instead of substring, I will use left. If it is somewhere in between, I will use substring. Okay. So I'm writing left concat left product line here. Okay, that's great. Very good. So if I go ahead and type the concat here, I'm getting here the first three letters CLA, but I'm creating a code here right now, a custom code here. So I will go ahead and write this in the uppercase. I will go ahead and write this in the uppercase. Remember to close the bracket for every function that you write. Now this looks correct. Very good. So first is done. Now after this here, I will give a separator. After this, I will give it here a separator. The separator, I'm giving a simple hyphen. Okay, a simple hyphen as a separator. Now go ahead. Now let's get the second part here. The second part here is a formatted by price with zero decimal. We know that the round function can go ahead and make it zero decimal, but there is a but the round function is used on numbers, and round function give output as a number too. Yes. Okay, so whether I use two number, two decimal, rounded, any function I use here, it will give me output as a number. Here, I don't need output as a number. I need a text out of that. Why? Because I'm creating a text right now here. I need a custom product code. I need the text out here. I need number as a text without any decimal. In this case here, we will go ahead and use the format function. Another function here, format. This format function here gives output as a text. It can do whatever round function can do, right? But this format can go beyond the round function. So for example, in the format right now, I will go ahead and get the by price here. I will type a comma and type 0. And that's it. If I'm writing it like this here, if I'm writing like this here, I'm making sure that I will go ahead and close the bracket here again and look at the output. So what is the difference between the format and the round function there? Right? What is the format and the round function there? The major differences between format and round function is format gives the output as the character, and round will be used on the numbers. The output will be a number too. Another major here about the format function can, whenever there is a huge number, right? Whenever there's a large number, big number there, in that case, format can actually give you 1,000 separators in the output. Format can actually give you 1,000 separators in the output. So if you want to go ahead and read a number, a big number properly, you will use format. So format will make it easier to read with the 1,000 separators there. Plus, you can use the format here to give a percentage sign too. So if you want to go ahead and format as a percentage, okay, format can be easily used for that too. However, the output is going to be a text. But yes, it can add a percentage sign at the end. So simply to add the percentage sign at the end, we can do that. We can use format. Okay. So right now we are halfway here. That's why we are using the format. Yes, Ritushna. Right? I'm directly using the format, just one function there. Once that is done, I will add the hyphen again because that is our separator. Now, after this hyphen here, the third here is unique reverse product code. So yes, we are going to use the function called as reverse right now. So this is reverse. What in the reverse here, I will simply go ahead and ask it that reverse the product code right here. Once this is the reverse code here, and I will close the bracket here for concat here. Now, when I'm closing the bracket here for concat here, let's look at the output, everyone. Oh, look at this. It is the exact mirror image. It is exactly mirror image of the product code right here. I'm going to name this as custom product code. Now let's look at the output right here. I'm going to beautify this too. This is how it goes. There is one thing that we forgot. Okay, what is that? We need only the sample of 5 rows. But here I'm getting the entire table. I don't want the entire table here in the output. What we want, only the 5 rows there. So if you want only the 5 rows there, we can go ahead and use limit. We can go ahead and use limit and limit the output to the 5 rows. So you'll get only 5 rows here. Right. So let's discuss few things here. So what we have seen so far, okay, we went through select. Now we understand few things about select. What do we understand here? That if we are talking about the select here, everyone, with the help of the select, we can add filter out the columns and attributes that we are looking for. We can add the aggregations. We can go ahead and add the calculated value, calculated columns here with different types of functions, with different type of functions there. From is used for any kind of schema name, table name, addresses there. Where gives us conditional or filter on the rows. After this here, we have got group by. What is group by, everyone? We always go ahead and group by any kind of dimensions or the categorical values here. What group by will go ahead? Group by will go ahead and create the aggregate reports. What does it do? It creates the aggregate reports here. It will aggregate the numbers in front of each category. If you know Excel, okay, it basically works like a pivot table. It basically works like a pivot table. What is having here? Having here is a filter. What is a having here? Having clause here is a filter. But this filter only works on aggregated value. It filters only aggregated reports generated by group by, generated with group by. So basically, if you know Excel, it works like a slicer. It works like a slicer, right? After this having here, you have got order by simply sorts. We have recently seen limit. Limit will limit the output in the result, right? So we will have to go ahead now and understand. Now here, we will have to understand group by and having. We'll understand group by and having, right? So this is the sequence, everyone, that we are going to talk about. We are going to go ahead and understand right now group by. Now, what is a group by here? Group by creates the aggregate report. Now, what is an aggregated report? So before I go ahead and show you an aggregated report, I will give you an example right now. So for example, here, if I ask you that what is the average buy price of the products? Okay, I'm going to ask you here that what is the average buy price of the product line, of each product line there, okay, of product line. When I ask you this here, usually we go ahead with select from product, select from product here, where, so select from product, but what we want to fetch here, we want to simply fetch here product line and average, correct? So if I, usually what we write, we will go ahead and write the average price here. What do we type in the average right here? Inside the average, I want buy price, so I will go ahead and get the buy price. Buy price. Okay. The average is somewhere 54, and that's fine. That 54 is the average there, okay? However, if I will ask you here that go ahead and get me the average price for each product line. So if I will ask you this question here, that get me the average buy price for each product line, in this case, what you will do? In this case, what you will do? What should the table, how should our table structure look like in this case? If I want average buy price of each product line, we should have 2 columns here, right? First column should have product line names here, product line names here. Second column should have the average buy price here. However, the first column here, should I extract the entire column? Should I extract the entire column that we have in the products table? Should I extract the entire product line column that we have here in our data set? We need unique list here, right? We will need unique list of the names here, unique list of names here. Why do I need unique list of names at product line here? For a very simple reason. If this is the product line, for example, this is the vintage cars here. This is the vintage cars here. This is the motorcycles here. They should be written there here only once. So that in front of that, we can go ahead and write the names, right? Calculate the average for that. Now, how do I get the unique list of names here? So group by actually tells the select function. Group by actually goes ahead and tells the select function that, see, I'm giving you this list of names here. Okay. Go ahead and filter them out and then calculate the average. So it is just not the unique list of names here. Okay. Group by will also inform select that, see, you have to group by with each of these names here. Okay, that's why unique and distinct will not work. Why not? Because group by is specifically informing select function that, see, group by vintage cars, group by motorcycles, group by this and that. So it will, what is group by? Group by means select will go back to the entire database. Inside the database here, it is going to filter out vintage cars. Okay, then it will go to the buy price. It will calculate the average. Then it will filter over. Now I have to go ahead and type group by because this is the writing sequence. And in the writing sequence, I will say that this is the product line. This is a categorical variable right now. Go ahead and tell selector here that product line should be extracted out, but it has to group it by here and then calculate the average price. So when the group by will inform that, then only it will get the product price here. Okay, that is why group by works, not the unique. And first we will go ahead and have, we will see the group by in detail, right? When we are talking about the group by here, within the examples here, we are going to use all the functions that we have learned so far. And within that, we will learn about date functions too. After the date functions here, or within the date function here, we are going to also explore here order by and limit. So we will have some practice exercises. We will see some different scenarios here. And we will have the entire practice exercise there. And now afterwards, we will go ahead and we talk about the logical statements. So we will see that when by logical statements, in this you will have if else, and we will also talk about case and memory. And after that, again, we will combine everything here. And we have been working only on one single table, right? So we go ahead and we talk about join. What is join? How many types of join are there and more. So this is the today's agenda. As the time and the speed will be there, we will go ahead and try to cover this today. It should contain only, however, it should contain only motorcycles, vintage cars, trucks, buses, and trains. We have done this before, but here is a little twist. Now, we want the average MSRP of the product lines, but not all, only for motorcycle, vintage cars, trucks, and buses and trains. And once you get that, okay, the average price that you will calculate, the average price that you will calculate here, average MSRP here, it should be less than 100. It should be less than 100. And of course, you will go ahead and order it properly. Go ahead and list in the alphabetical order of the product line. Go ahead and sort it in the alphabetical order of the product line. Okay, so I will give you a simple guidance here. First, tell me how are you going to solve it? Let me tell you the steps here. Okay, let me tell you the steps here. First step, which table are we working with? Which table are we working with? First, let's decide that. I'm giving a correct way or guide to solve it. Which table are we working with? Which table? From which table? Do we have to apply any filter here? Do we have to apply any filter here? Where are we applying the filter? In which column? Okay, so we go inside the products table here and we are applying it in the product line column. Product line column. right? And which function are we going to use here to filter out product line column? Which function we should use here? Function or anything else? Which operator do I use here to filter out the product line? Yes, we use the in operator here. Within the where clause, we use the in operator here. Very good. Do we need to group by? Do we need to group by? By which column do we group by here? By which column do we need to group by? Product line, not product name, product line. Because that is what we are using here. That's what we are going to use here for filter out product line. Okay, and select is what we want in the output, right? So what we want in the output here, only two columns, product line. In the select here, first column is product line. What is the second? This average MSRP for individual product line, it is not present in the data here. Meaning, if I have to filter this out here, I have to use the having clause here. And why are we have to use the having clause here? Having is simply a filter. All the operators that you can use in where, you can use in having also. But having only works on a report that is generated with the help of group by. So under the having here, we'll say that go ahead and get this calculated column average MSRP, okay? And make sure that it is less than 100. Now, if we type this here, okay, we see everything will be less than 100 here. There are too many decimal points, right? So I'm going to go ahead and write round function here. Inside the round function, let it be there with 2 decimal points. Right? Now this looks much better. So this is how we use group and having. Remember that having is used in the aggregated report only. Also, if you will go ahead and beautify this, it will look much, much better and easier to understand. Once you understand this part here, we have to still go ahead and learn a lot more right now about group by. Now, right now with the group, now we know how group by works, right? So now we are simply going to move forward with the date functions. But now whatever we will see here, okay, you have to determine whether the group by is going to be used or not in a certain scenario. So we are going to explore a few date functions here, right? And we will explore group by within the date functions here. So let's see the first question here. Total number of orders placed each year in the orders table. So go to orders table, right? Get the total number of orders placed each year from the orders table. Go ahead and get from the orders table. So what do we want in the output? In the output here, we are looking for, so first let's look at the orders table, okay? So this is the orders table right here. And these are the columns from the orders table. Now it is saying that you need to count the total number of orders here. You need to count it. So what do we count for total number of orders, everyone? What do we count? So now here, we know that we need to go ahead and count the order number right here. Great. But it is saying that placed each year from the orders table. So from where do we get the year, everyone? We are going to extract the year from the order date. Order date is the entire date here. We can go ahead and extract the year. Meaning, how does the output look like? In the output here, we should have year as the first column. And then here, we should have total number of orders. And here, we should have total number of orders. Right? That's what we are looking for. Easy. I want year-wise total number of orders. Should we use group by here? So let's go ahead and write this out. So first thing that I'm going to get away with, that is select everything from the orders table. Once that is out here, now I will begin. So from the orders table here, we are looking for first year column, right? And from where I'm going to get the year column? From the orders date here. So how do we extract year from the orders date? We simply use the function year. simply use the function year. And we'll get the year order date. I'm going to call this as order year. I'm going to call this as order year. Now, after this, we want to count the order number. So we can simply go ahead and count. And we can get the order number here. I'm going to call this as total order. I'm going to call this as total order here. Total orders here. From where are we getting this? From the orders, but we have to go ahead and group by 2. Now in the group by here, we have just one category here. So we can type group by 1 and we are good. Use the beautify here on the right hand upper corner here. All right, this will help you to view your written query in a much better manner. And you will be able to actually understand, oh, this is what we have counted. And now what we want right now, we want to go ahead and find out which day of the week has most orders placed. Now we are absolutely aggregating there, right? So first here is, I'm going to go ahead and fetch this right here, because this is what we are doing here right now. The only thing that we have to change here is now we don't need the year here. What are we looking for? We are looking for weekday. So how do we get the weekday here? So to get the weekday here, I'm going to type day. And see here, I've got day name, day of the month, day of the week. So what do I get here? I will first get day of the week. Day of the week. And inside the day of the week, what we have? Order date right here. Now we'll go ahead and count by order number. Now here, I will go ahead and get day of the week first, and I will execute this right here. Once I execute this, what do I get here? Order here. And since I'm grouping it by 1 here, I'm getting here total order by individual day. Now I have no idea. Okay, so I'm also going to order it by, 2. Wherever I have got the highest order, that's what I want to see, most orders placed. So I will order it by the total number of orders. If I do that here, I need to do that in descending order. Okay, so 6 day 69. Currently, I have absolutely no idea, okay, whether one is Sunday or a Monday. And how do I go ahead and name them? Right? Yes, correct there. So what we do here, we will now go ahead and get the name. What we do here, we'll go ahead and get the name here. So now I'm writing here that, okay, I have day of the week, but now go ahead and get the day name. Inside the day name here, we will go ahead and write only order date. I'm going to name this order date here as, I'm going to name this as order week number. This is order week number. And I'm going to name this as order week name. This is order week name. Now, since we are writing 2 categorical variables here, we'll go ahead and in the group by, we have to write group by 1, 2. 1, 2. Now, if I go ahead and execute this, now we know that, okay, it's Wednesday. 6th is Friday. Now, I have to change the order by. Order by should be 3. Order by should be 3. So now we get 6 is the Friday, and this is the total number of orders here. Highest total number of orders is Friday. Yes. I would like to remind you, we are using the column numbers here. So my first column is day of the week. Second column is name of that particular day. Third column is the total number of orders. So we have ordered by total number of orders here in the descending order. Yes. Now here we have learned about this year and month thing. And this is one type of order here. Why I'm giving a hyphen here? Because I want a hyphen to be written here. The code is just %y, %m. Now, what will happen if in the similar query here, right now, we have written y and m in caps, correct? So when I'm writing y and m in caps here, what am I getting? In the output, I'm getting full name of the month and 4 digits of the year. Look at this. This is what we are getting here, right? What if I go ahead and write lowercase lowercase y and lowercase m here. So I'm going ahead. I'm going to type lowercase y and lowercase m. If I do that, I get 0301, 0302. What am I getting here? Only digits. What we get here? Only digits. So here, this y will give last two digits of the year, and lowercase m will give us simply month in the numbers. Right? Now there is one more. There is one more. There is B is also there. Okay, what B gives us? B gives us abbreviated month. What is abbreviated month here? Let's look at that. So I'm going to copy and paste it again here. And instead of M here, I'm going to go ahead and type B, a small case B here. And I get this. Okay, I can also go ahead. And what if I will write it like this? Now it is January 2003, 4, and 5. If I want to make it better, here, we can go ahead and combine this here with B and Y here. And this looks much better. Yes. So let's see the next example here. Again, this is an exercise, everyone. And this is an exercise here. It is going to combine whatever we have learned so far. And of course, you'll see another function again. So here, we want to retrieve the average days between order date and ship date for each month. So every month, what is the average days we are taking to ship the order out of our warehouse, right? So I want to see how many average days are we taking to ship the order out of the warehouse. So we want to go ahead and see the difference between these two, and we want to calculate average about that too for each month. However, it says that show only the results where average is more than 5 days. Why somebody wants to know that here? So what we want here is I want to go ahead and figure out that in each month, how much average days we take to ship an order, right? And in here, I'm saying that I simply want to see all the orders here wherever the average is greater than 5. Now, why would someone needs to know that? Because if we are taking more than 5 days just to ship the consignment, it means that that person is going to receive maybe once I've given the order, okay, that person consignment is not reaching them before 10 days. If it is going to out of the warehouse after 5 days, it means that there is something not good at the processing. We need to optimize the process of the entire process of after receiving the order, what goes out in the warehouse, whatever is going on there, we need to optimize that process. And when it is happening and why it is happening, if I want to find that out, I need to know where we are taking, in which particular month we are taking more than the average of 5 days, right? So that's what we want to know about. So let's go ahead and see how to see the difference between the two. Where is the ship date and order date? Here. Ship date and order date is here. So what we need here, I'm going to go ahead and type select. And I will first write that we are taking it from the orders table right here. Very good. Now inside the select, please understand here, we want to go ahead and deduct order date with the ship date. Now how do I do that? And that too by month. So let's go ahead and get the month out first. So this is the month here. I'm going to get the month out from the order date. That's there. So I'm calling this as order month. This is order month right here. Now after this order month, what we want, difference between the two dates. To find the difference between the two dates, the function is date diff. You will find this date diff in Excel. You will find this date diff in Tableau. You will find this date diff in Power BI and almost every BI software out there. So date diff gives us the difference between the two dates here. Of course, in this, we'll simply give, okay, this is the last date, recent date minus old date, new date minus old date. That's what we do here. And since it is the row level calculation and we want to calculate average by month, we will go ahead and average the date diff here. We'll go ahead and average the date diff here. Fine. If I calculate the average date diff here, I'm going to call this as days to ship. Days to ship. From the orders, right? Of course, we have to go ahead and group by month here. That's what we are looking for. So we will go ahead and group by month. Month is 1. That's fine. After group by here, it is asking us the average. So now we will get the average days to ship here. We have the average days to ship here. But what we want to see right now, we want to go ahead and see only where the average is more than 5 days. Everything else is fine. Less than 5 days is good. So here we go ahead with having. And to the having, we will say that this, what I've calculated, days to ship, right? So I have to go it without any space here. So I will say that having days to ship here should be greater than 5. If it is greater than 5, right? Oh, only the 10th month here. Which one is the 10th month? So I will go ahead and add here month name. I'll go ahead and add the month name here. From the order date as month name. Month name, comma, here. Let's look at the output right now. Oh, I don't have the correct output. Why? I'm writing everything correctly. This is month order date. Now I need month name, then I need average from the orders and group by. What is wrong here? Why I'm not getting the output? Yes, very good, Santanu. If I'm adding 2 categories, I need to mention this category in the group by also. So group by 1, comma 2. If I type 1, comma 2 here, I get the answer. Yes, very good. So now I get it is October month and days to ship is 5.56667. I don't want that much average here. We can round it off. So I'm using the round function here. We are rounding it off, everyone, by 2 decimal points. Now, when you're typing this, you have to be very careful with the parentheses that you're writing. We are using a nested function, round, nested by average, nesting the date diff function here. I'm going to beautify this so that it looks properly written here. Give me a moment. It is showing unexpected error occurred. It's okay. It is showing unexpected error here. So now let's understand about the roll up, everyone. Okay, so what is roll up here? Adding subtotals and totals in the report. Now, before I go ahead and use it right here, let me show you an example first so that it is easier to grasp. So this is an aggregated report. Okay, in this report here, we are getting year here. This is, let's say, a month right now. And here we have got the quantity. Okay, how much quantity we have sold out. So let's say here I'm talking about 2005. And of course, now I have got multiple months from 2005, for example. Now here I have 2006, 2006, 2006, and likewise. Okay, so this is what I have here in the years. Now, in the similar manner, in the month here, what do I get? So let's say I'm getting everything for January, February, and March. So here also I'm getting for last quarter only January, February, and March. Okay. And here are the quantities ordered. Here are the quantities ordered. I'm just writing some random numbers here. Okay, great. Now, what is the total, everyone? What is the total here? What is the total quantity? What is the total quantity, everyone? A simple grand total. This quantity column. Total that up. How much is it? 15. So total quantity here is 15. So I'm going to write 15 here. This is our total quantity. This is what it is. It is the grand total here. This is the grand total here. All right. Now, if this is the grand total here, can you please tell me the subtotal of years? Can you please tell me the subtotal of 2005 subtotals here? Can you add the subtotals, everyone? You understand, right? If I will go ahead and calculate year-wise total, it will be called as subtotals. We understand that the subtotal, it will be called subtotals here. For 2005 and 2006. Right. Yes, 9 and 6. So here the subtotal here for 2005 is 9. And here subtotal will be 6. This is what we want to do when we are doing group by. Yes, very good. So this is our objective. This is our objective here. Now we want to go ahead and add the total and the subtotal here too. So those who use pivot table, they know this happens automatically in pivot table. So if we have two categorical variables, we get automatically subtotal and grand total right there in the pivoted report. Remember that? We have switched on and off the subtotals in the tabular and the outline view in the Excel. Okay. So that's how we get it. Now let's go ahead and see how do we do that in SQL. Do that in SQL here. Now here, let's go ahead and see. So what I want here, let's go ahead and see how do we add the grand total and the subtotal here. So let's go ahead and get where we have year and month together. Do we have year and month together anywhere? Here we are. I'm going to go get this first one here. So we are going to group it by year and month. So after year here, let me get month also here. I'm getting month right now by order date. Order date. I'm going to type this as order month. This is order month here. This time we'll remember to group by 1, 2. And let's count total order numbers. Okay, and here we go. So right now, here order month is 1, 2, 3, 4, 5. So instead of 1, 2, 3, 4, 5 here, I will also go ahead and get the month name just to be precise. Just to be precise. Okay. So that I know which month we are talking about and we are not confused between total orders and the order month here. This is order date. I am also getting here name of the month here. And we remember here to type 1, 2, 3 and group by. Now we are good. So now what we want here is we want to now go ahead and add the order month and the month name right here. That's what we want here. So what will happen if I don't write this part? I'm simply showing you. Everyone, remember that you are not working with me. Okay, I'm showing you here. Let's say it looks like that we don't need order month at all, right? We are having month name, then why do I need this number here? So let's remove it. So I've removed it. See, now I have year, month name, and count. Done. If I go ahead and execute it right here, let me remove 3 from here. And this I get. Okay. Good. So right now we can see 2003, January, I have total 5, and February we have 5. Now what we want to do here, we want to add the subtotal and grand total here. So in front of group by, I will simply go ahead and write here with roll up. With roll up. If I write with roll up here, it will actually add that here. However, now since we don't have month number here, it is going to forget that the January should come first. It will now sort this in the alphabetical order. That is why month number is necessary. However, right now we'll work like that to understand grand total here. So this is the 2003 total, everyone, right? Then it is, here we have 2004 total right now, subtotal here, 2005 subtotal. At the end, we have grand total. Go ahead and look at this, please. Go ahead and get the group by with roll up here. It will add the grand total and the subtotal here. Before you ask, let me go ahead and answer your question right here. That we can here in MySQL, to replace the null value, there are few preference settings that we have to do. And as an admin, that permission should be given to us to actually write those codes right now, where we can replace this null value with some other values here. So all these are the reference settings, everyone. Preferences settings, sorry. Since those are not done, we don't have the permission right now yet. And by default, it is set like this. So we are not able to replace the nulls. If, else, case, and when. Okay, we are going to go ahead and talk about if, else, and case, and when. That is the logical statements right here. Now we'll go ahead and talk about the logical statements. Now, why logical statements? We had comparison operators, we have and, or, between. So we have got logical operators and comparison operators. Then why do we need logical statements too? So when you're applying and, or, between, or anything, okay, you're looking at your two or more conditions. So here in the logical statements, why do we need this here? We need logical statement when if I check, for example, and condition in the output, what do I get? Do I get any output out there? No. It simply helps us to filter things out. It only helps us to filter things out. Logical statements here help us to add a calculated column, But this calculated column is a logically calculated column. It's a logically calculated column. It is not mathematical. For example, right? For example, I want to go ahead and assign a performance category to employees based on their job title, right? For example, I want to go ahead and assign a performance category to employees based on their job title. To understand this question here, let me show you the employees table. You can see our employees table here. We have got employee number, their personal details out there, their manager details here, and the job title right here. So based on the job title, we will go ahead and set their performance category. Done. Or we can go ahead and we can go to customer table and we can categorize the customers based on their credit limit. So if their credit limit is good, we can categorize them as gold. If their credit limit is somewhere between average, we can go ahead and categorize them as average. And accordingly, we can target them to sell credit cards, right? So that's how it happens. So let's go ahead and see how do we go ahead and assign a performance category to employees based on their job title. So every time we'll go ahead and check what is happening inside it, and then we will move forward with that. Step by step we'll go. So let me show you an example first. So there are two examples, everyone, if and else and case and when. So let me show you how if works here. So if here works as a function, not as a statement there, but it works as a function right now, if. This if is exactly similar to Excel. Okay, in this if here, first we'll go ahead and assign the condition. Now that based on that condition here, you can get two outputs, value if true, value if false. And that can go ahead and give us the two outputs right there. If you have multiple conditions to check, so this can help us with one condition and two outputs, right? So if we have multiple conditions and multiple outputs, multiple conditions to check and multiple outputs, everyone, we will go ahead and apply nested if. And this nested if is going to be exactly similar to what we have seen in Excel. So let's go ahead and see an example here. So first we'll see a simple example, and then we'll go ahead and look at more examples there. So first example is going to be customer table to assign categories based on the credit limit here. So what are we going to do here? We will go ahead and say that go ahead and assign high credit. Go ahead and assign high credit If the credit limit is above 50K, if credit limit is below 50K or below, right, categorize them as low credit. Categorize them as low credit. Now, where we will be writing this if function, we want to add a calculated column, right? So for example, here, this is the customers table here. I'm going to get select. So I'm making, this is select everything from customer. So I'm getting this at least out, and then we will talk it more. I don't want all the columns right now. What are we looking for? I am only looking for, let's say, customer number and their name and their credit limit. That's what we are interested in, right? If we have this output here, what we simply want to add one more calculated column here in which we are going to say that go ahead and read this 21K and tell me what is the category there, right? So let's go ahead and write it out. So to add a calculated column here, we will go ahead and type within select. We'll go ahead and type within select. So I will type a comma here. I'm going to next line because it is going to be a larger function. See, this is the if function, simple function here. Opening the bracket up, what is the condition here? Condition here is to check 50,000. So I'm going to selecting credit limit here. Credit limit, if credit limit is above 50K, if it is above 50K, comma, what should be the output? High credit. Because it is greater than 50K. If this condition is false, what should be the output? Low credit. Easy, same as Excel, everyone, same as Excel. And of course, I have to name it something. So I'm going to name this as customer category. Right, so while you're writing this here, while you're using this if function here, let me show you here. See, it has added the calculated column. That's what we are looking for. And that took perfectly figuring out the numbers right there. Yes. Now here, if I will go ahead and reformat it, I will show you the reformat version, everyone. This is the reformat version. This is, I'm copying it right here, pasting it here, and reformatting it. See, much better. All right, so this is what we have done yesterday, everyone. And of course, we have seen conditional statements. We have seen comparison operators plus the logical conditions too. And with this, we have been looking at multiple different date functions also. So we have went through multiple date functions, string functions, logical functions, plus logical conditional statements too. Today, we are going to begin with the join, everyone. With the join here, we are going to go ahead, understand what is joins, what are the different types of joins out there. And once join is completed, we are going to talk about normalization, constraints, and we will discuss about the DDL statements too, that is data definition language, where we are about to create the tables too. So while learning joins only, we are going to go ahead and create the table right away. So before we move forward, okay, we have to understand joins first. So this is today's agenda. This is what we are going to cover today. Now, what is join here? How many of you are aware about the joins here? Have you ever heard about the joins? Are you aware about that? Right. Have you ever used VLOOKUP in Excel? You know about VLOOKUP in Excel? Yes. What do we do in VLOOKUP? We fetch the matching values from one table to another. That's what we do. So if I have, let's say, a customer number here in one table and customer address in another table. So based on the customer ID, we can go ahead and fetch the customer contact number from one table to another. Right. So it means that this table here, so when we do that, what happens? Wherever we are merging the tables here, that entire table is called, will be a merge table because it is going to contain data from both the tables together. So what is joins here? What is joins here? Joins is when we want to merge two tables together horizontally. So let's take an example. What are the different type of joins in SQL? In SQL, you'll find here inner join, left join, right join. These three are basic joins. You'll find them everywhere. Of course, the fourth one here is full join. Fourth one is here is full join here. It is also a common join right now. And the next here is self join. Next here is self join. Next here is self join. Now, after self join also, we have one more join called as cross join. So you'll see what is that. What is join here? Join is a method of merging two tables together on the basis of a common column. That is joins. Now we'll go ahead and understand the join one by one. To understand the join here properly, all right, I'm going to show you example and then we are going to move forward and understand what these joins are. So in a very simple language, if I say, okay, joins are very simple. We simply want to merge two tables together based on a common column, and that is joins. Wonderful. Now we can see here, there are two tables, everyone. This is the orders table here, and this is the customers table, right? So if this is the orders table here on the left-hand side, we can call this table 1 or left table. And since we have placed the customer table on the right-hand side of the screen, we are calling it table 2. So here we have got customer ID, everyone, and here we have got customer name. Okay. So do we have the two tables, 1 and 2? And what is joins? Merging the two tables based on a common column. That is joins. Very simple. Now I have one question with you all. Okay, if I want to go ahead now, see this is the orders table. Okay, in this orders table here, we already have got customers detail. For example, we have got their customer IDs here and which particular product they have bought and the price they have paid. We already have this here. So why to go ahead and keep the name of the customers here, right? We can go ahead and fetch this customer name right here. So can I go ahead and copy paste customer name just like this because I want to merge both the tables together? Can I simply go ahead and copy and paste the customers list here to merge the table? Yes or no? And I'm talking only about this example that is in front of you. So we cannot do that. If I cannot do this like this, if I cannot do this here, okay, what do we do right now? So forget about VLOOKUP. Okay, those who don't know, because there were some no's in between for VLOOKUP. So if I will go ahead and I want to fetch the customer name here. Now we want to merge two tables. That's what will happen at the end. We will merge two tables here horizontally. It is based on a common column. Which one is the common column between the two tables? Customer ID here is the common column between the two tables. Here, this is the customer ID and customer ID here. Now, how do we go ahead and get the customer name here, everyone? So if we have to go ahead and do it manually, right? First we will go ahead and read that, okay, this is CR1. Once we read this is CR1, we will go to our second table and we'll try to find CR1 here. So the CR1 is John. Once we find this out, we will copy and paste it. So this is John here. I'm going to copy and paste it right here. Now this is again CR1. So we understand that this is also John. CR2, we'll go back again and we'll try to find CR2 here. Now this is Peter. Now we'll go ahead and find CR3. And accordingly, we will go ahead and fetch one by one everybody's name here. So here I have found CR3, CR4 here, and I have copied and pasted them right here. This is fine because now we are matching on the basis of the common column. Now, do we have CR6? Let's find the CR6 here. Do we have CR6 here? No. So what we do here, since we don't have the name here, we'll leave it blank. We can keep it null. That the customer details are not updated yet. Yes. So now the merge is completed. Have we merged the two tables together right now? This merge is completed, everyone. So the customers who have paid the order, we have got their names here. So what we just did right now, okay, this is called as left join. This is called as left join, everyone. This is called as left join. What we did here, okay, we went ahead. What we did here right now, We simply, based on a common column, we fetched the names here, right here. Now, why we are calling it the left join here? Okay, why we are calling it left join? Have you thought about this CR5 here? Have you even thought once about the CR5 while fetching the values here? Okay, so right now, while we were matching the values, everyone, while we were manually matching the values here, did we ever once thought about the CR5? So the CR5 is not present in the first table here. CR5 is not present in the first table here. Okay. So did we ever think about the CR5? No. While we usually merge the table together, when we usually merge the table together, we make sure that whatever data we have in our left table, that data should remain intact. That data should remain intact. This is what we want. And that is why we only go ahead and worry about the data which is matching from the second table, which is matching from the second table. If it is matching from the second table, we will fetch only that particular data here. We don't care if something is not present in from table 2. We only get the matching data here. And this kind of join or this kind of merging of two tables is called as left join. It is called as left join. So why it is left join here? Because we are keeping all the rows from the left table and getting only matching values from the right table here. That is why we are calling it left join. Do we understand this now? That why it is left join? Because while joining it, we are keeping the entire left table intact. And we get only matching values from the table number 2. It is one of the most common joins that you will see. 90% of the time you will be using left join because first table is always going to be your master table in which you want additional information to be fetched. This manual process is called as left join. That's it. The entire manual process that we did, it is called as left join. However, you don't have to do it manually. If you will ask the SQL to do the left join here, from the backend, it will do this process. Okay. That's left join. So if this is left join, everyone, what do you think the right join will be? If left join, in the left join, if we are keeping the left table intact and we only fetch the common column or the common values from the second table, what do you think right join will be? Master table will be right. And we will go ahead. In the right join here, we are going to keep the second table intact. We are going to keep the second table intact. Right. So what is this? So here in the second table, we want customer name, right? So we are going to keep the customer ID and here we will get the customer name. This will remain intact. Of course, this also remain intact. Even though it is not present there, this will also remain intact. So this entire table should be there. And then only get the matching values here. And see here, now CR6 will left null. Why? Because we are only fetching the matching values from the left table here. And the right join is not used here. There are very less, there are lesser examples or real-time scenarios where left join has to be used. Right? So left join is left table intact, right join is right table intact. Now what will be the inner join here? Inner join means it will only keep the matching values from both the tables. It is going to keep only matching values from both the tables. So which are the matching values here? These are the matching values, right? So it is going to keep only matching values from that table. Only the matching values. Yes, correct. Common records across both the tables, right? So this is inner join. Okay, we can see here we have CR1 and CR4. So do you see any difference between the left, right, and the inner join? A very visible difference here. What is the difference? What is the difference that we are looking at here, everyone? Look at this here. In the left join and right join, they will have null values. Okay, left join will have the null values because some data will not be present in one of the two tables. So here left join and right join are bound to have some null values. However, inner join makes sure that there are absolutely no null values here. But in this particular scenario where we have the order table and the customer table, okay, please tell me here, is the inner join the correct way to merge both the tables for analysis or report creation? Is inner join where we are keeping only the matching values from both the tables? Is this the correct way to join both the tables? Understand this, everyone. If I want to go ahead and analyze this table here, if I want to go ahead and analyze this table here, this is not a good way to join the table. Why? Look at this. Look at the orders here. I have only 5 orders here. And we are eliminating one row entirely, this one row entirely for CR6 because this person's name is not available. Maybe that person has refused to give their name on the till. Maybe they are not the registered customer with us. So on the cash till, they decline to share their personal information other than the card. So I might not have their name here for any particular reason. But because of that here, this entire transaction is deleted from the inner join. And is this good for the analysis? We are compromising the data here. Okay. So this is why inner join is not. Why I am telling you this? This is how you decide. Okay. This is how you decide which join is required. Most of the time it is the left join. We use inner join only when we are sure that we don't want any null values there. And if certain information is not available about the customer, remove the entire customer. So in that case, we can go ahead and use the inner join. So there are multiple scenarios on the basis of which we have to go ahead and choose the join here. Got it? Great. Thank you. Do we understand what is happening in inner join and in this particular scenario, why it is not good? Because we are compromising a huge order here just because the name of the person is not available. If I'm doing the order analysis here, I don't need name of the customers there. And I need all the data. So we don't want to compromise our data set here. Now next is full outer join. What will be the full outer join? Any guesses out there? What will be the full outer join here? What is left? So what is left right now? We have got the left table intact, right table intact, matching values from left, matching values from right. In the inner join, only matching values from both the tables. What is full outer join now? Full outer join is going to it will return everything. Okay, it will return everything from both the tables. It doesn't care whether there is a common column or whether there is value there or not. It is going to go ahead and extract the tables, extract all the rows from both the tables based on common column, of course. Right, it will keep both the table records and it is going to have multiple null values too. So full auto join is usually avoided. Okay, and for a very simple reason. For example, now when do we use the full auto join and why do we avoid the full auto join here? Let's understand this. For example, I have customer details table in the classic models, remember? And now I want to go ahead and see how many of them have placed the order. How many number of orders they have placed. Remember? So now to know about that, I have to go ahead and join both the tables together, customer table and the orders table together. And then we will go ahead and see that how many orders have given by one customer. So for example, here, this customer has given 2 orders. So, but a CR5 has not given any order. So in my output, I don't want CR5 there because this person has not given any order. Then why do I need this person in the list with a 0 sign there? I just simply eliminate all the 0 persons. Those who have not given any orders till now. But if I require the customer details, which has given 0 orders, right, I will go ahead and do the full order join. So usually if someone has not, I want to count the number of orders given by individual customer. However, if I will go ahead and do the left join, I will only keep the customers who has actually placed the order. So my minimum order number will be 1. However, if I want to go ahead and actually analyze that which are the registered customer who have not given any order in the past 6 months or in this particular quarter, I will go ahead and do a full order join. And in the full outer join, we will simply count again. And this time, wherever is the null value is there and the count is 0, there we will know that, okay, these are the customers we need to focus on, that why they are not placing the orders there. Again, it is based on necessity and the objective, that which type of join is there. Usually, we avoid the full outer join. These are the four basic joins, everyone. After this here, we have got cross join, self join, and natural join. So this join is known as natural join. This join here is known as natural join. So we have got join, natural join here. What is natural join here? So if you're working on a database and you have no idea what is the common column there, if you simply write the join there, it will go ahead and find the common column based on name should be similar, of course. If the name is similar, you simply write join, it will go ahead and find that common column and merge them together. What are the self and cross join here? We will go ahead and understand these two here. First, let's go ahead and see how we perform these joins in SQL. Okay. So I'm going to move back here. And first thing that we have to do is we have to go ahead and create a small table, right? We'll go ahead and create a small table, everyone, two small tables, and then we merge them together. And once we understand how to type the joins properly, once we understand the syntax, the typing rules of joins, then we'll go ahead and see better examples or complex examples in joins. Okay. Great. So here, let's go ahead and create a database. Now, first, how do we create a database here? So we understand from the first class, right? We can simply go ahead and write create database or create a schema. In MySQL, it will be exactly similar thing. And once we create this schema here, afterwards we will go ahead and we create the tables. After creating the tables, we'll go ahead and insert the rows. We will go ahead and we insert the rows right there. So this is what we are going to do right now. So let's go ahead and create a fresh schema, everyone. So we are going to go ahead and create the schema first. So I'm typing create here. You can type a schema or database and MySQL, they will be both similar. I'm going to name this here DB joins. I'm naming this as DB join so that we remember why are we creating this join here. Why are we creating this database here? So this is the create a schema. And this is the DB joins here. Okay. I'm going to write here use DB joins. However, I will be keep using the name of the schema because I have no idea whether you will be who is going to make it default or not. So I will make sure every time I will be still using the joins here. Now, since we are using the joins, since we're using the this create table for the first time, now after this here, we will create a table. So how do we create a table? Very simple, create and table. Now, after create table here, once we write create table here, we will go ahead and name the table. How do we name the table here, everyone? We will go ahead and first we have to write the database name, and then we go ahead and we give the table name. And if you have properly made sure that the database is default here, then you might not need to write the database name here. So here also, you'll go ahead and listen first. Now, once we have given the table name, what we do next, we'll go ahead and start typing here the column number 1 name. So first we'll go ahead and type the column 1, column name 1. So whatever is the first column here, that name will be written. And then after this, we'll go ahead and give the data type, comma. Then we will go with the column name 2. So whatever is the second column name, we will go ahead and give the data type there too. And likewise, we will go ahead and keep on writing the column with the data type till the end. So this is a very basic table creation, and that's how we create a table. So what we will do when we type create a table here, we are simply preparing the structure of the table here. Only the structure of the table will be prepared, not the entire table. So let me show you how does a structure looks like. So here I'm writing create table. Where do I want to create the table? We want to go ahead and create the table inside the DB joins. And inside the DB joins, I'm typing the name of the table here. Let's name the table employee info, a very simple table here. This is the employee info. Now, after naming the table here, now we will go ahead and give the column name. So if it is the employee info table here, the first column that I'm getting here is the employee ID. We can add employee ID there. Maybe the 4 characters are fine. It can be alphanumeric characters also. If we have employee ID and employee info, we can add employee name also. So here I'm adding employee name. Employee name here, now we cannot be very sure about it, that how long it will be. So maybe let's keep it 50. Let's go ahead and get their skills also there. So skills are going to be wildcard again. So I'm making this also here 50. After skill set here, let's get their experience, number of experience in years. So let's keep that as integer here. We can keep that as integer also here. Once we are done with the columns here, we can close the bracket and put a semicolon here. Now this will only create the table structure. What does that mean here? It will go ahead and create the columns entirely. So I'm going to select this here and execute and refresh here as usual. Once I have refreshed here, I can see the employee info right now. In this employee info here, I'll click here on the right side. It will go ahead and write the select query for us and see. Only a structure is there, absolutely no details inside it. So if you go ahead and look at this, it is a simple structure of the table. All the columns are here and we can, there is no data there. So you can also go ahead and describe it. You can also go ahead and describe the DB joins from employee info, and you will find that this is the field, this is the character type. Okay, and there can be null values can be there, and there is no extra any constraints or limitations are there. But what we have here is the name of the field or the column and the data type that we have given. Now, once you have the create table here, now we go ahead and insert the values. Now, once we've created the table, everyone, what we need here, we want to created the schema, created the table. Now we will insert the values inside the empty table here. How do we insert the values here? How do we insert the values here? We will go ahead and we will go ahead and simply type insert into. Insert into. And in the insert into here, we will go ahead and type database name again and the table name again. Inside this table name again, we go ahead and we type values. Now inside the values here, what we will do, whatever is the employee ID one, we'll add that. Whatever is the employee name one, we'll add that. So if it is a text, it will be added inside the double quotes like employee ID, employee number, employee name out there, whatever skill set they have. And the experience that we want to add is an integer. So here we'll type a number, any number here. So maybe 9 years of experience like that. So this is the one record or the one row. Now we type a comma, and in the similar manner, we go ahead and we add another record. And like this, we'll keep on adding individual record one by placing comma, comma, comma. Right? So this is how we go ahead and we insert the values here. Now, if I want to insert the values here, so I'm typing here insert into DB joins employee info. This is what we want. So we're asking it to go ahead and insert into DB joins employee info, and which values? Values are these. So here we want to go ahead and insert the values. Now in the values here, okay, maybe our employee ID here is, let's say, A123. And here I'm catching some name here with the experience. So I'm also copying, pasting. I'm not typing and wasting my time in typing individual record. Like this, I will go ahead and get more records here. So listen to me very carefully. I am also not wasting my time here in typing each and every one record right now, because our main focus is learning joins. So I am also copy pasting the insert into here. Now, everyone, please listen to me very, very carefully right now. This insert into DB joins here, it has to be executed only once. Why? Because right now we are not placing any limitation or any condition here in which we can save it to not create the duplicates. So execute the insert into only once. You will not see anything immediately. Okay, you will not see anything immediately. You don't need to even refresh. Just execute it once and then look at your table. This is insert. See what I'm doing here. I'm selecting the entire, I'm going ahead and selecting the entire insert from the start till the end. Now I am executing it only once. That's it. Okay. In the output here, you can see it has perfectly, we have the output here, 5 rows affected, and there is a green check sign. Now, once I see that once, that's enough. Now we go ahead and execute the select everything from, and you will immediately see the output here in the result grid. So please remember, execute it only once. If you'll execute it twice, all right, you are going to have multiple duplicate values. And I will not help you right away to remove the duplicates, because for removing duplicates, we have to use the update there. Okay. Update there. Update keyword. or there. So I'm not going there right now. Right now we have got just one single table. Now let's go ahead and get another table too. Okay, so now we need another table. So for another table also, we are going to create another table, DB joins employee salary design. So this is another table, everyone. Employee salary design. So designation here. So we have got employee ID, this is designation, and the salary is float. Now again, after this here, we will go ahead and insert the values. This is the insert the values here. So very simple. So here, only 4 rows we are inserting right now. This is the designation L1, L2, L3, and this is it. Since we are writing create table and insert continuously here, please listen to me once again very carefully. Those who are not paying attention, you are going to get the errors if you won't hear. Listen to me properly, please. Come back and listen. Right now, you can see we are creating a second table, everyone. We are currently selecting a second table here. I'm telling you here how to execute it. Okay, how to execute this here. So this is the table number 2 that we are going to create. This is table 2. Now in this table 2, what I did, I have written create a table and insert into together. These are the 2 separated statements here. I'm going to select the entire 2 statements together. After selecting entire statement together, create also and insert out also from the start till the end. Now we will go ahead and execute this from the first lightning bolt, because first lightning bolt executes all the statements inside the selection. So we'll use the first lightning bolt here after selection, and then we refresh it here. The moment you will refresh it, you will find your employee salary designation to be added in here. Okay, so what we are doing, we are selecting this entire thing, and then we are executing here and refreshing here. All right. So this I've executed now. Now I'm going to refresh it, and you will see salary design right here. Of course, now we can go ahead and view this table. This table will look like this. So please remember, that's how you execute this here. I'm going to share this with you right now. Please go ahead and get this table. You should have 2 tables there. And this is how you will execute this. Select everything together and execute only once. So the first table here, everyone, okay, it looks like this, where you have employee ID, employee name. These are the skills that they have. These are the experiences here. This is the employee salary design. We have few employee IDs, their designation, and their salary details are here. Now let's go ahead and see multiple joins in between these 2 tables right now. So first here is, okay, make sure that this DB joins is default. Make sure this DB joins is default. Now we'll go ahead and apply multiple joins. So first, let's go ahead and talk about the left join here. What happens in the left join? We keep first one intact. So first, let's see how do we type a join here. First, let's see how do we type a join here. So to type the join here, we will simply go ahead with select. And this time we want all the columns from where? From both the tables, remember? So now where the join is written from in the address section. In the address section, that is from. Because right now we need whatever output we need here, even it's all the columns or few columns, any output that we need from both the tables there. So now inside the from here, we go ahead and we define the join. So select everything from where we need from 2 tables here. So we first is the employee info, we double click and we get the name here. We want to join it, right? We want to go ahead and join this. So what type of join? Left join. So here the keyword is available, left join. So you'll simply use the keyword left and join. So here we can see left and join. So from we are selecting a left join right now with which table here? With the employed salary and designation here. Is this fine? Or should we need to give more information here? Should we give more information here? Is this fine? Do you think from this with this much information, the SQL will be able to join both the tables? What information we need to give here? What information do we need to give here? Yes, the common column. So now we go ahead and we give the information about the common column. Now, there are 2 ways. Now see here. Okay, after this here, there are 2 ways to give this information here. First is the keyword. using. This using keyword here, okay, we go ahead and we tell them that the common column between these two tables here is employee ID, right? So by utilizing the using key, by writing using keyword, we can go ahead and define that. But we use this particular keyword only when we have exactly similar name, exact same name. So this using here, okay, to define the common column, can only be utilized when the column name, is exactly same in both tables. Now in real time, this is actually not, it doesn't actually happen like that. So if that doesn't happen like that here, okay, what we use here, we use the on keyword. What does on say here? So on here, in the on here, we will say that, okay, go to employee info table, and in the employee info table, employee ID is a common column, right? Which is common to what? Which is common to employee salary design, which is common to employee salary designation. Inside this table, you will find employee ID again. So basically, we are going inside and we are giving the entire column name and the table name here. Right? Okay. So this is how it can be written. This is how it can be written too. So let's look at the output here. So this is the output from the using keyword. Look at the output. See here, from the second table right now, we have multiple null values here. Why? Because we are fetching only matching values. So here, not many is matching here. Only the employee ID 123 is there and 126 is there. All other employees are not present in the second table. So we are looking at multiple null values right here. This is the output from the using keyword. Now let's see, is there any difference if we get the output from on here? If we get the output from on here, let's look at the output here. Again, the output will remain same. It is a left join, but now we have A126 common here. Everything else will be null. So this is left join, everyone. And in the left join, we can easily see the left table is kept intact and we are only getting the matching values from the second table. Now, have you observed any difference between the two outputs here? One output was from using, another output is from here. So see here, this is the using output, this is the on output. Do you see any difference? So when we are typing using here, to define the common column, we are seeing the employee ID column only once. We are seeing the employee ID column only once here because using consider employee ID is common in both the cases. So it will keep it only once. However, when we are using on here, on assumes that both the employee ID column spelling might be different. So it is going to give us the employee ID column, the common column from the second table also. It will fetch the common employee ID from the second table also. Using is not doing so. So sometimes we do need the employee ID here from the second table too. Because if I'm having the employee ID from the second table here, okay, see how easy it is to recognize which particular employee IDs are not present in the second table. However, it was not that easy to recognize here. I have to go all the way back here to see, okay, which are missing. However, if we are using on here, which is used 99% of the times, we can easily see which are missing right here. It is easier to filter out and everything. So this is the simple left join, everyone. Now here, if we go ahead and write like this, it looks really long, right? So what we can do here is we can go ahead and use alias here. How we can use the alias here? Very simple. We'll keep this exactly similar. So from employee info, let's name this table number one. And this I'm naming as table number 2, right? Now when I'm writing on here, so when I type table number 1, okay, it refers to employee info. See employee ID, employee name, experience, and skills. Now I will say go to table number 1, fetch the employee ID, which is going to be equals to table number 2, employee ID again. it is easier to write. It is easier to write. Our output is going to be similar. So that's how we write any kind of join. So whether you're writing left join, right join, inner join, this is how we write. This is one way to write. What do you think we will write? How do we write right join here? If this is how we are writing left join, how do you think we will type right join? So what we do here is for the right join, everyone, I'm going to copy and paste the exact same thing here. I'm copying, pasting exact same thing here. And instead of left here, we'll go ahead and type right. Instead of left here, we'll go ahead and type right. So here is the right join here. And this is how the right join looks like. You can see the right table is intact. And we are getting the null values in the left side. Yes. Now, how do we write inner join then? We go copy and paste this again. We copy and paste this again. And instead of right, we type inner. And now look at the output, everyone. See, we know that only two are the common rows here, and we're getting only those two rows out here. So please write the inner and the right join. Then I will show you another way to write the inner join. Then I will show you another way to write the inner join, which is used most of the time. Because then we are going to talk about how we can type inner join in one more way. Because inner join is basically all the rows that are this employee ID equals to this employee ID, right? That's what an inner join is. So we can simply use a where clause also to type the inner join because we are actually getting whatever values are similar in both the tables. What if we want only selected columns from table 1 join? We will see multiple examples too. We can go ahead and select all the, we can go ahead and select the columns which we want to view. Right now, I'm showing you all the columns here, Saurabh, because we are simply trying to see how does joins work. And as we move forward, we are going to have multiple examples. We'll see how to go ahead and select individual columns there, okay? And we'll learn multiple examples once we are done with all the types of joins. We are still left with full outer join and cross join and self join. When all the types of joins are done, then we'll do some practice exercises where on classic models there, where we will be including all the type of functions and calculations we have seen so far. So I'm going to simply show you that this is the kind of this is just one problem I'm going to show you here, but these are the type of problems that we are going to solve. So I'm simply sharing an example with you. Once all the types of the joins are completed, okay, we are going to go ahead and solve these kind of solutions there. So have patience, you might learn something new. Now let's see here another way to write the inner join, right? As I have been talking before. Now what is inner join here, everyone? Inner join, we are writing that in both the tables here, that employee ID should be equals to employee ID. So we can simply define the inner join with the help of the where clause. We can also go ahead and define inner join with the help of the where clause. Because in the where we can easily write, okay, that employee ID should be equals to employee ID. So we can go ahead and write the inner join like that too. So we are going to create the inner join with the where clause here without using the inner join keyword, without using the inner join keyword. Let's see how. So first thing will remain intact here. This entire thing will remain intact. That select from the table 1 and table 2. That is fine. That is fine here. After this here, instead of using on here, we will type our where clause that we are familiar with. And inside the where clause, we can simply go ahead and write this that from the table 1, employee ID is going to be equals to employee ID here. And this is the way we write most of the time. So see here, I'm going to close this result here. If I go ahead and execute it, this is how it is going to look like. So this is inner join. Okay, we can write it with the where clause directly. And here I don't need to use the inner join. Yeah. So how I don't use the inner join, I will type a comma. Now I'm not typing the inner join here. I'm typing employee info table 1, employee designation table 2, where table 1 is equals to table 2, and we get the same here. I'm going to beautify this here so that you can clearly see how it is written. If we use the keyword here, this is how it looks like. This is how it looks like when we use the keyword. And this is when we are not using the keyword at all. We're using the where clause without the inner join keyword. Go ahead and get this inner join. Then we are going to talk about the full outer join. Most of the time, okay, we will be writing inner join like this. It is easier to write, okay, still we get the similar output. No, so we cannot. Because in others here, okay, we are very specific that I want to keep one table intact, another table intact. In inner join only we need exactly equals here. In no other join, we need exactly equals. Now, let's go ahead and understand about the full outer join. Now, in full, when we go ahead and want to type full outer join here, in MySQL, there is no keyword like full outer join. There is no keyword like that, as you have left join, right join, and inner join. So instead of that, what we do here is we go ahead and what is the full outer join in real time? Full outer join means that we need the output from the left join. This is the left join output here, right? This is the result grid here. And just this is the left join here. And now we have got right join output. This is the right join output. So what we want to do here, we want this output from the left join and the right join to be typed one below the other. That will become the full outer join. Yes. So let me remind you the full outer join here from the smaller example. What was the full outer join here? So this is my left join output. This is the left join output with one null value. And this is our another right join output here with one null value here. And what was the full outer output? Left join and the right join both together, one below the other. Yes, that's full outer join. So here we will go ahead and append both the outputs together. To append both the outputs together, we will go ahead and use a keyword called as union. Union here, simply copy paste the two tables, one below the other. That's it. That's union. So this union is also called as append in Power BI. You will find this union in Tableau also. This union will do, it will go ahead and copy paste both the result grid one below the other. And after that, it will go ahead and remove the duplicate rows from the output. It will go ahead and remove the duplicate values from them automatically. We don't have to do that. So basically what we do here, we go ahead and we combine the left join and the right join together. And both the outputs together are going to give us the proper full outer join. So look at here, you will get the gist here. So this is the left join, everyone. This is the left join here. So I'm simply copying, pasting the left join. This is the left join. Now I'm getting the right join here. This is the right join, right? Now what we are saying here is whatever output I'm getting from left join, I want to combine this with output we are getting from the right join. So in between these two here, I'm going to go ahead and type union. And of course, it is one single statement, so we don't end it here. We end it at the end here. So I'm typing union here. If I'll go ahead, select and execute all, look at the output. So A 121, 122, null. Only the common ones are 126. I'm getting the null here. This is the full outer join. There is one more keyword called as union all. There is one more keyword union all. What does it do? It will go ahead and get you the entire rows here. So can you find out the common columns here, common rows out here? So this is A123. This is A123. So right now this is A123, right? This is also A123. So these are the common rows here. Similarly here A126 is here. This is also common when we copy and paste the result grid one below the other. So there are few common rows in the output right now. Yes. So here there are multiple times the employee ID is repeating. Multiple times employee ID is repeating everywhere. So union all is not able to remove the output. It is simply going to copy paste the result grid as it is. That is why we use union keyword here. Union keyword will remove the duplicates right away. See, now the employee ID in the output is going to remain unique. So there are two keywords here, union and union all. Union all key here keeps the duplicate values intact. So union all does not remove the duplicates. It will keep the entire rows as it is. Okay, it will not remove the duplicates. So I will also go ahead and write it for you here. And what we use for the full outer join? For the full outer join, we use union. Go ahead and get this, please. So these are the four basic joins. These are the four types of basic joins here. Once you are done, we will go ahead and see the next joins, that is the cross join and self join. So I have given you an exercise right now. Let's go ahead and understand how to break it down and write the query here. Okay. So first here is how do we break it down here? First thing, we understand that which columns do we require here. Now, which two tables do we need here? From where do we get customer number and customer name? We get it from the customers table, right? We get it from the customers table here. Now, from where do we get the order number and the year? We get the order number and the year from the orders table, from the orders table here. Now, of course, orders table have order number, but orders table do not have the year. So what we do here, we do have order date. So we can extract the year from the order date. We can extract the year from the order date. And these are just the four columns that we need. No calculation, nothing, no aggregation. So a very simple join here. However, they're also asking us that for the year 2005, meaning we have to go ahead and filter the year 2005. That's it. We have to filter the year 2005. Now, this is what we want to type. So how do we begin here? It's step number one. Okay, remember the order of execution here. So I'm going to write select first and everything first. And I'm going to figure out from here. Okay, from here, because I need to join two tables right now. So first I'm going to type join properly, and then I will go ahead and apply other operators here or select columns. So inside the from here, which table do we need right now? Customers table, right? So I will double click in customers table. I'm naming it C just for I'm naming it C here. Now remember that use classic models, please. Remember to use classic models. Make sure it is default. So our query doesn't go very long here. So I think I should write it here. Right. So here we have customer C here. We want to join it with the orders table. So tell me which join should be better. We want to see all the customers along with the orders they have given. So we want to see order IDs in front of the customer's name. So please tell me which join we should be doing here between customers and orders. We need the customers and their order IDs in front of them. If we will do the left join, what will happen? We will have all the customers, right? And what we are going to get? Only the matching order IDs. What will happen if the customer has not given any order? What will happen if the customer has not given any orders? This left one is left outer only, Saurabh. So what in the left join, my customer table remain intact. All the 122 customers will remain intact. Okay. And now we will fetching the order IDs there. What if those customers are present, but they have not given any orders? Then what will happen? We'll have null values. Now what we will do here? If I do the full outer join, I will get null values at both the tables. Will it solve the purpose having that many null values? Inner join, everyone, inner join. Why? Because I need customers who have placed the orders. So if the customer exists, then only the order will exist. Do we understand this point here? If the customer will exist here with us, then only the order is existing. Why? Because customer number is the common column between the two tables. Which one is the common column between orders and customers table? Customer number. So customer number has to exist in the customers table also. Then only they can place the order with us. So the correct answer here, inner join. Correct answer here is inner join. If customer has not placed the order, I don't need to go ahead and see that. Why do I need the null values? We don't need the null values here in the output. So customers here, inner join. And we need to inner join it with the orders table. I'm going to name this as O. Now, after I've named it as O here, we will go ahead and join them based on common column. So on C dot customer number, and this is equals to O dot customer number again. Till here, the join is done. First, I've written the join here. Now, what is the next thing here? Filter. We want to filter the year 2005. So how do we apply filter everywhere? With the where clause. So after from, I'm writing where clause here. So in the where clause, do we have year inside the orders table? We don't have year inside the orders table. So what we should do right now? We can extract the year. So here I'm typing year and we're extracting with the order date, right? So extract the year order date and it should be equal to 2005. If I go ahead right now and execute this, I'll get the entire customer table. So look at here. And now here I'm getting the entire order table too. Credit limit, customer table is done. Now here I'm getting the order date here exactly from the 2005. Of course, we don't want the entire table to be joined here. We want few columns to be extracted. So here we will have all columns in the output. All columns, and now we will select columns. Selected columns. So how are we going to write selected columns here? So let me show you here. So if we are looking for the selected columns here, okay, it is pretty clear. We need customers. We need customer number, customer name, order number, and the year. Meaning we need two columns from both the tables here. So this is how we define it. So from this customers table here, we want customer number. From customers table again, I'm looking for customer name here. Then the orders table here. This is the best practice. If you will not define from which table you are getting, in few cases you'll get the answer. In few cases you won't get the answer. So be careful. Inside the year, from the orders table, I need the order date. If I go ahead right now and execute this, I get the answer. So here I'm not defining from which table I'm getting it. I'm still getting the answer. But the best practice is define from which table you are getting this column. Okay. Yes. Define from which table you're getting this column here. C and O are aliases, right? I will go ahead and clearly write this here. I am writing like this here because we don't have to type AS every time. Even if we don't type AS here for alias, okay, it is still understand that C and O are alias. Okay. Give this a proper name, that's it. I'm going to beautify this so it is easily visible to you what we are typing. And let me tell you how many rows of output are there. So we have 64 rows. We have got 64 rows, everyone. Now we will explore few more types of join there, and then we will do similar type of examples here. Okay, we'll go ahead and we will do similar type of examples from here. So let's go ahead and understand what is a cross join, everyone. So till now, what we were looking at that we want to merge two tables together, right? Now, what is a cross join then? So to understand what is a cross join here, let's see our Excel right now. So what we have here, okay, what we have here, we have got order details and customer details, right? Now, what is a cross join here? Cross join here is a Cartesian product of two tables. Now, those who are from the, those who remember the mathematics, they remember the Cartesian product. Those who don't worry about it. So what is the Cartesian product of two tables? Let me define it for you here. What is a Cartesian product? Let me go ahead and show you here. So let's say this is my table 1. Okay. And this is my table 2. Table 1 here contains A1 and A2. So these here, let's say these are the customers. Customer A1, customer A2. And here, in the T2 here, okay, what I have here, product. So this is here product 1 and product 2. Now, what is a Cartesian product? So if I go ahead and merge it using the Cartesian product, how is it going to look like? So I'm going to have table 1 and table 2 here. And this table 1, A1, in front of A1 here, I will get a combination of P1. With A1 here, I will get a combination of P2. Then with A2 also, I will get a combination of P1 and the P2 here. Meaning, this is combined with these two here. A2 is also combined with these two here. There is no consideration of common column. That's Cartesian product. Meaning each row will be combined with all the rows in table number 2. So this row here, CR1, it is going to be combined with each and every row in the table number 2. This is Cartesian join. I join here. I understand that at first it doesn't make sense that why do I need the combination of everything out here? Doesn't make sense at all, right? But it is useful in a few use cases. It is very useful there. For example, okay, you have to go ahead and do an activity right now. And you simply you want to do an HR activity right now, and you want to give a certain task to everyone. So there are few tasks that has to be done by each and every person. So there is a game, and in that particular game, some task has to be done by each and every person out there. So you have the list of the people, and here you have got all the tasks. And these tasks has to be combined with each and every person right here. So there is no common column consideration here at all. We simply want the multiple different combinations that are possible. So with CR1, every other combination is there. CR2, every other combination is there. That is cross join. Now, at first, cross join doesn't make sense, and yes, it doesn't. But let's see how to write it, and then we will see a real use case here. So first, let's understand how to write this cross join, and then we will go ahead and see what is the real-time use. What can be a real-time use case here? So basically, what it is showing us, cross join is a Cartesian product of two tables right now. And this is simply showing us multiple combinations, multiple possible combinations. So how do we go ahead and write the cross join? There are two ways to write the cross join. Okay, one way here is to go ahead and ask it to select again and everything from, and what we use in from here, what we type in from here, both the tables. We can use cross join here. So let's create a cross join again. We are going to work on DB joins, not in classic models. So please remember that to make sure we are using DB joins here. Here we go. Now select everything from where? From the employee info table here. I'm going to name this as, for example, there is absolutely no common column consideration, right? Let me write that here also. No common column consideration. So I don't need to name it also, table 1, table 2, because we are giving the alias for a very simple reason, because we wanted to go ahead and give the common columns there. Since there is no such common column consideration, I'm simply writing cross join it with the employee salary and designation table here. And that's it. That's it. So if I go ahead and execute this right here, okay, this is how the output look like. Look at the output right now. For each A1, 2, 3 here, entire table is pasted in front of it. Again, A1 to 4 here, entire second table is pasted in front of this. What is the other way to type the cross join? Other way is to use where? To use simple query. Simple query here. How to type a simple query? To select everything from employee info, comma, employee salary designation table here. That's it. I don't have to use where also. I'll simply go ahead and type comma here and enter. I still get the same output here. This is cross join. This is cross join here. So let's go ahead and look at a simple example right now. See, I understand this output doesn't make sense. Why do we use it? So let me give you a use case scenario here. what is the use case scenario? So let's say there is a restaurant there, okay, and they have created two menus. First, they have created for the food, another they have created for the beverages. Now they want to go ahead and create a combination menu. So you go to restaurants, right? And they have some combo offers that this is a combo offer. If you buy this combo offer, you get this much discount. How they're creating that? They need some random combinations of that, right? So yes, do you go to restaurants? Do you ever seen the combo offers are there? If you combine these three things together, you get some discount, right? So usually their food menu and beverages menu is separated. However, sometimes they run the offers. So we are supposed to look at their two separate menu cards, combine them together, and determine their combo offer price. Does this make sense? You go to any online application or you go to any restaurant there, anywhere, there are always combo offers available. So how are they deciding that these combinations should work out and what should be the pricing for that? Okay. So let's go ahead and create a new database again. Okay, so here we go. So we will create a new database. First, look at the cross join here. So at least confirm that are you able to see the cross join? Even though the output doesn't make sense, but we know this is how the cross join is written and this is how it works. Okay, so we will go ahead right now. We create a new database here and I'm going to call this a cross table. Why I'm calling it a cross table? For a very simple reason, so that we remember what we have seen in this side, this cross table here. So this is, I'm creating a database. I'm calling it cross table right now. Here we are. And I'm going to call this table here food. I'm being very simple here. Inside this cross table here, I'm going to go ahead and call this as food. Now inside this food here, what are the columns I'm going to keep? First, I'm going to keep the item code. An item code, let's keep it character, 3 characters here. After that, let's get the item name. After this, let's get the item name here. Item code, here we have got item name. Item name can be varchar. It can be a varchar here. And I'm keeping this here as 25. We'll keep some small food names there. And of course, their price. Of course, their price. Price, let's keep it float. It can be in decimals. So this is float right now here. And will go ahead and close the bracket here for the table. So table is created. Now inside this table here, let's insert some values. I'm not executing the table right now. I'm going to execute the create table and the insert into together. So I'm typing here insert into. Insert into. This is cross table food. This is cross table food. And the values here. Values here are, let's say we want item code here. So this is 1, 2, 3. This is the values. Let's food name here, everyone. Okay, so first food name that comes into my mind right now is pizza. So here we go. Let's go ahead and give some price to it right now, like this. It's pasta, right? A small word here again, and comma. Okay, so I'm using one more here. Fries is the smaller name, so I'm going to use the fries here. So I'm simply giving some random numbers here, everyone. Okay, so this is some random values. And yes, this is it. So we have created a food table right now. So I'm going to select the entire thing here. I'm going to execute with the first lightning bolt and refresh it here. And we have got our food table right here. This is our food table, everyone. This is how it is going to look like. Okay, great. Now go ahead, create the food table, everyone. Then we are going to create the beverages table, 3 beverages table, okay? 3 names in the beverages. Again, these small names here. So I'm going to create another table right now in the similar manner as we have done before. Okay, I'm going to call this as beverages. Now inside the beverages table, again, what we are looking for, beverages code first, right? So I'm going to write here beverages code first here. And that code should be again character. Let's keep it 3 characters again. We want beverages name right now. So I'm typing beverages names. And we will keep it wildcard here, same as the table there. Now their prices, beverages, prices here. This price we are going to keep float. So here table is created. Now let's go ahead. Table is created. Now let's go ahead and insert the values. This is the insert values here. Where you want to insert the values? Cross table beverages here. I'm going to type here values here. And now I need beverages here. So let's say the beverages code here. So this was A. Let's keep it 1 here. So this is B12. The first I can think here right now is tea. So I'm naming the first beverage as tea. Okay, I'm going to give some price here to it. And we are good. Coffee is good. Coffee. I can write it quickly. Just because I can write it quickly here. Okay. I can write Coke or Cola. Yes, correct, correct. So here we are going to go ahead and write B here 14. B14 here. And like, okay, let's write Cola here. Fine. So we got the 3 here. Great. So I'm writing some random numbers here, okay? I'm not thinking it about much. This is our random number and we are good. Now I'm going to select everything here, execute it once, refresh it, and I got beverages and food. So now let's see how do we go ahead and we write the cross join here. So we have got both the tables here. Now how these two look like here? So the beverages table looks like this. So this is our beverages table, everyone. This is the beverages table. This is how it looks like. And let's look at our food table right now. This is our food table here. Now we want to go ahead and see multiple combinations of this. In this case, the cross join will come in handy. So I'm going to simply write select everything from cross table food here, comma, cross table beverages. I don't even need to write the cross join here. If you want to, go ahead and do it. We are going to get this combination right here. Look at this right now. All the fries here, these are the fries here, right? Look at this here. All the pizza, they are combined with all the beverages. All the pasta combined with all the beverages. Fries combined with all the beverages. So we do have food combinations right now. But is this the output that we are looking for? We have to also go ahead and get the total price, right? So let's say that first we will go ahead and get the total price of this food combo. And then we will get a discounted price also with the 10%. So this is how we are typing the cross join. Okay, if you feel confused here, no worries. We can go ahead and type cross join also here, like this. Still we get the same answer. Okay. So let me show you here how we can go ahead and get the total price for the meal combo here. So this will remain exactly similar. No changes here. This will remain exactly similar here. However, now we go ahead and we select which columns do we need. So after selecting all the columns here, okay, after all the columns, what we need right now, now we will go ahead and do the calculation here. What calculation here? We will go ahead and say that now here, I will go ahead and name it T1 and T2. Why? Because I need to use this in calculation right now. So I'm using here T1 here, that from the T1, that is the food table here, get the item price and add this to the beverages prices here. That's what we are looking for first. Okay, so this becomes the total price. This is going to become the total price here. This is a total price, but out of this total price here, we want to give a 10% discount, correct? So first, let me write this as total price. This is total price without any discount. So if I give this as a total price, this becomes total price. Simply added up both of them here. Done. So this is total price. We understand this price here. Now what we want a discounted price added. and we want to give a 10% discount. So if I want to give a 10% discount here, please look at me, look at the screen, please, and tell me, can I go ahead and write it like this? That's 7 multiplied by 90%. And can this 90% can be written like this? That multiplied by 0.9. Can we write it like this here? Total price multiplied by 90%. Does that mean 10% discount? Do we understand this part? This calculation here? Yes? Great. Wonderful. So this is what I'm going to do here is I will go ahead and get the total price first. So this is my total price. And in front of this total price here, I'm going to simply multiply this with 0.9. 0.9 means 90%. And this is going to be our combo price. This is going to be our combo price here. If you look at the combo price, there are too many decimal points. So maybe we can round it off to, maybe we can go ahead and round it off to 2. So I am rounding it off to 2. So I will go ahead and give more parentheses here. And now here I will take this. Or let's round it off altogether. Yeah, this is 2. So we are now here. So here we go. Now, right now, cannot write total price multiplied here because select get this as the output. I cannot type total price within select. If I select and execute this here, we have got total price and combo price. Why we cannot write this here? Remember, the select here, okay, at the end, it is doing the calculation within itself. So the total price is not coming from somewhere else. And select will get executed at once. It will not execute it once, all, then this. No. So whatever you write here, it has to come from the database directly inside the select query. Remember the execution plan. Select executes at once, not one by one. No. Remember the execution query? We have talked about that. What is the order of execution? In that, when select gets executed at the end, right? It is going to get executed at once. It is not one by one. It is going and fetching, going and fetching. And once it fetch what and inside the select, you have to go ahead and tell select to go back to database and get something because that's what select understands. It is not going to read its own calculation and on top of that, it will do its own calculation. It cannot do that. I'm also going to go ahead and write this here, okay, with the reformat option because reformatted actually looks better. So this is the combo price here. So this is, these are the cases, okay, maybe you want to go ahead and create a product mix out there. So you have some flavors with you and you want to create the product mix, for, let's say for shampoo also, for toothpaste also, and every other product that you have here. You want to create the mix with the flavors. So maybe you are selling out soaps, shampoo, conditioners, right? And now you want to go ahead and mix with some 3-4 flavors you have in hand. And the flavor should be repeated in everywhere exactly similar, of course. For conditioners, shampoos, everything, soaps that you have here, of course, the entire flavors will have their own separate mix. So in that case, also you can simply go ahead and create the combinations within that. This is the cross join everyone and one of the use cases of that. Once you have seen the output, you understand the cross join, we will move to self join first. We'll move to self join here. Again, it is a very self join is very, very different from all the joins that we have seen so far, even different than the cross join. Let's go ahead and see self join. Now, what is a self join here? Now, this is something very, very interesting part here. It is not even a cross join. It is even different than the cross join here. Why? Because in self join, what happens? In cross table, at least we are using two tables to join together, right? What we do in self join here, in the self join here, we simply go ahead and join the table with itself. What we do in the self join here, we go ahead and we join the table with itself, meaning we need only one table and we join it by itself. Why do we do that? That's the question here. Self join is done whenever we want to go ahead and create a hierarchy. Whenever we want to go ahead and create a hierarchy. So we'll have the one table only, and we will create the join based on the common column that is there, but that column will be saved within the same table there. And why we do this? Just to create a hierarchy within a table. Okay. So for a few things about the self join that you should remember, that there's a special type of join here that we can create by itself by using inner join. There is no specific keyword for the self join here. And why do we commonly use the self join? Just to create the hierarchies within the table clearly. I will give you the example, don't worry about that. So that it is easier for us to retrieve the interconnected data within the same table, For example, and there is no specific keyword called as self join. We will use the inner join. To define the self join here. Now let me give you an example, a very simple example here. So in the classic models here, we have the employees table. In the classic models here, we have the employees table, right? In the employees table here, please see right now, these are the employees, right? These are the employees, everyone. And these employees reports to someone. It means these people are the managers. They report to someone. It means these people are the managers. And this is everybody's designation here. This is the designation of everyone. This job title here is for everyone. This job title is for the everyone. Okay. So that's how it is working right now. So reports, in the reports too, any employee ID that is here, that can only exist if they are the employee. Do we understand that? These are managers, everyone. They can be managers only when they are employees. Yes or no? They can be managers here only when they are employees of the organization. We understand this part, right? So for example, let's talk about the employee 1002. This person, is it reporting to anyone? No, because this person is a president. 1056 is Mary. Okay. Is Mary reporting to someone? Yes, Mary is reporting to 1002. And who is Mary? Mary is VP sales. Who is Mary? Mary is VP sales here. And Mary is reporting right now to president. That's how this data is created. That's how this data table is created. And the way I'm trying to explain this right now, okay, this is not a very, this is a quite confusing table right now. Quite confusing here. Okay. What if, instead of designing this table like this, what if I can go ahead and type like this? What if I will say here that first I'm going to go ahead and keep the manager ID. Okay. Then here I'm going to have the manager names here, manager names. And of course, the manager title, manager titles. After I have all the manager details, then I'm going to go ahead and get the employees who are reporting to them. So now I will have the employee ID. Now here I will have employee ID and now the employee name, and their job titles here, their employee job titles here. If I go ahead and create the table like this, will this make more sense? Easy to read and understand that, okay, to which manager who is reporting. Yes. Reason is if I go ahead and write it like this, reason is if I go ahead and write it like this, then it will become actually easier for us to identify what goes where. So maybe this manager is 1002, right? To this person, if two employees are, and this is let's say person name is A here, and the manager, this is the president, okay? And here the employee ID 1058 here is, name is Mary, okay? And their job is something, and here and another 1098 is there, okay? And this person is also reporting directly to this person here. Let's say Mary is also a manager. So if Mary is a manager here, I will go ahead and say this is the manager here for marketing maybe, and to this person here more 10 people are here. So it is quite easy to filter it out, quite easy to understand what's going on, right? So this is the restructuring we want to do. What we are trying to do here, restructure the entire table. Now we don't need two tables for that. So in this case, self joins comes in. In this case, self join comes in here. What we do, what we ask self join to do here is that go ahead and join this table with itself by using the common column this and this here. Once it will do that, what will happen? Let's see the output. Okay, if we will go ahead and write this here, let's see the output here. So I'm going to go ahead and type the self join right now. So to type the self join here, we will go ahead and just simply type the inner join instead of self. There is no keyword, so we will simply go ahead and type the inner join here. And the join will go exactly similar as we have seen so far. This is select everything, every column we need right now. From where? From our employees table. This is employees, right? And I'm going to name this as E1. And this has to act as two tables. This has to act as two tables here. So I'm going to go ahead and write inner again. This is inner join. And again, we will get the employees table. And this time I will name this as E2 because virtually it is going to join and give us the result. That's the temporary output there. Now we will go ahead and type on. So here E1 is, we will keep the reports to here. In the E1 here, we are going to go ahead and keep the manager IDs first. So I'm going to go ahead E1 dot employee number. And we have reports to. So first I'm getting reports to here and equals to E2 dot employee number. So these here, first I will get the managers list, then I will get the employees list. So that's what we are looking for. If I go ahead and execute it here, this is the output that I get. Oh yes, I have to use classic models here. So make sure classic models is default again. And once it is default here, we will execute this right here. Go ahead, look at the output. This is not the output. Okay, we will go ahead and create a proper output, but we have to understand how does the entire self join looks like. This is the self join, everyone. Okay. Now in the self join here, look at the employee number, first employee number that we are getting here. This is the employee number. You're very surprised to see here, this employee number here. Okay, it is still going to be remain unique. However, when you look at the reports to here, you'll find that now reports to is getting repeated. 1002, 100, 1056. See, it is repeating that many times here. Meaning, here now, in front of the reports to 1002 here, okay, this particular column contains the manager ID. Wonderful. Now, if you will move here, okay, again, the employee number is here. And look at this employee number right here. Now, this is your manager IDs. This is your manager name getting repeated properly right now. And in front of these people here, you have whom they are reporting it. And see the job titles are properly present here. Now we can go ahead and simply pick up which columns we need in the output to get the structure table here, structure table out. So first go ahead and get the entire table, look at this output properly and pick out which columns do we need in the output. So scroll towards left is scroll towards right and look at the output right now. The second table that you will see, you will find this contains only the details of the managers out there. So see here, President, VP Sales. You are looking at Sales Manager right now. Here, VP Sales, Sales Manager. So the persons who are the managers here, and then table number 1 here, you will find all the sales representative here. Those who are reporting to someone. In this job title, you will not find the president. Why? Because the president is not reporting to anyone. So the first employee number that you are looking at here, this is the entire result grid. Okay. The first employee number is your actual employee number. These are the reportees. So this is your employee number here. And this is the where is the job title? This is the employee job title. This is the employee job title. And this first name and last name that you see here, this is the name of the employee only, name of the employee. But the second part that you see here, okay, this is now your manager ID. This is now your manager ID. This is your manager ID. And here only you have got your manager name. And at the end here, you will got the title also here, job title. So automatically it is going to go ahead and give us this here. We now simply go ahead and pick up the columns that we need. So now let me show you here how to pick up the columns here for a restructured data. So this is fine. This is fine here. Okay. We are going to simply pick up the columns here. Now we don't need all the columns. We want to pick up few columns from here. So I've deleted the asterisk sign. First, I need employee number from here. So we'll go to employees here. I'm selecting that get me the employee number. And this employee number is coming from E1, right? So this is coming from E1 here. So first I need manager ID. So let's get the manager IDs first. So from E2 here, get us the manager IDs. That is employee number. This will become as manager ID. This is manager ID right now. In front of manager ID here, okay, we are looking for the first name and the last name here. Okay, you can go ahead and do the join also here. I am not doing that right now. So from the second table here, I am only getting the first name right now. Okay, this is the manager name. This is going to be the manager name right here. After the manager name here, from the E2 again, we will go ahead and get the job title. From the E2 here, let's get the job title. This is the manager job title here. So this is manager title. Now we will go to E1. Now we will fetch the employee's detail here. So this is employee's number. So this is going to be the employee ID, the people who are reporting to someone. Same here, E1 dot employee's first name here. Of course, you can go ahead and use the concatenate here. And I'm naming this as employee name right now. And then we have the job title. So E1 here, get the job titles too. So this is here. Of course, we will name this here as employee. Right. Let's look at this here. The output right now. So here we have got managers. These are the managers, everyone. And these are the employees. Those are reporting it to them. And we have the proper titles here. The simple restructuring of the data set. Simple restructuring of the data set here. I will go ahead and reformat it. I will also go ahead and reformat it so that we are able to read it properly. See right here. So self-join simply restructures the data set. So whenever you have a hierarchical data set like that, it will help us to restructure the data set as we want to.
And with that, we have come to the end of our course. If you have any doubts or questions, ask them in the comment section below. Our team of experts will reply to you as soon as possible. Thank you and keep learning with Simplilearn.